Again, welcome to the MicroStream Advanced training. And let me just introduce myself. MicroStream is used as a storage, especially for, we use MicroStream as an example on the German airport, Fraport, and also on the Allianz insurance company. MicroStream is already used, and I'm the project manager of these projects. I'm a software developer for 13 years now. 13, that should be okay. And I'm part of MicroStream since 2019. About the course, this is the timetable. So we started at 10. So we do around 2 lessons, then we have a little break till 12:30 CST. Then we go to lunch at 1:15. Marcus Kett will join the training to do some roadmap stuff to the year 2023, and then we go to the further lessons 4 to 7 and do all the other stuff of MicroStream. Let's talk about the topic. As I said, we start with a warm-up project exercise. Then we do some configuration advanced stuff. Just to I think it's nice to know how to change file naming and stuff like that, but there are 2 important things. It's the storage, creating the possibility or how to create or proper ways to create storages. And then we have some interesting topics are the channels and the housekeeping. And some parts you need to know about MicroStream and how MicroStream works in the background. Then we do some storing advanced stuff. That's also quite interesting, how to use the different storing strategies. There is an eager one and it's a lazy one, and you should know when to use eager or lazy. Then we want to talk a little bit about transactions and a rollback functionality. And in the end, of course, exception handling is a small topic within that part. After that, we go on with the lazy loading part, and I would say that's the most important part of that training for today, especially because lazy loading is, you have to know a lot about lazy loading and also how to create a proper object model. This is really important to use lazy loading. Then we want to talk about concurrencies a little bit, and in the end, the lazy legacy type mapping. That I think that's also an important part, especially a lot of people ask always, okay, what happened when classes changed and so on, how to handle that within MicroStream. Then we talk a little bit about some customization stuff, type handlers, class loaders, and store behavior. And if we have enough time, we can do a small performance demonstration, and of course, question and answers. And I would say question and answers are, in my opinion, the most important part of the training. So ask as many questions as you can. That's important. Okay, further informations. The sessions are recorded. You already know that. You will get access to the recording afterwards. So we will send you the recordings. And you will also get access to the code repositories of all the demo projects. So every time I start a new project, I will copy paste the link to the GitHub directly to the chat, so you can code along with me if you want. And all the projects are they have different branches in the project, so you can do it step by step. As I said, ask as many questions as you want. So just the basic URLs, the MicroStream documentation, you can find it here. Then there is also MicroStream GitHub. with a lot of different example projects in it. And in the end, it's my GitHub. Especially, you will find all the trainings on my GitHub account and all the examples for the training on my GitHub account. And at the end, I will share a link at the end of the training. This is a link to a Google form, and you can enter your name and some further stuff to get a certificate at the end of the course. But yeah, as I said, I will share this till the end of the training that you are able to get the certificate. Okay, so any questions so far or any adds from your side? Otherwise, I would go further and I will step into MicroStream itself. Just do some small explanations about it. Okay, so let's get into it. To summarize MicroStream a little bit, just an explanation. Okay, MicroStream basically, it's a Java framework. That is, it's not a server, and it's basically a Java framework you can use in every project, in every Java or Kotlin project you want. And basically, and at the beginning, MicroStream is a from scratch invented object graph serialization. So that's, in easy words, it is a way to serialize an object graph to different systems. It could be an AWS S3, there are Kafka, we have a serializer for relational databases, for DynamoDB, Redis, Azure, and so on, many more. That means at the end, you will get a binary format. So, and now comes the special thing. MicroStream is also able to update the serialized part partially. That means, let's say we have a customer entity, for example, and we serialize that customer entity and send it, for example, to AWS S3. And we change the name of the customer, for example. Then we can say, okay, customer.update, for example, or store that customer again, and then the customer will be updated on the serialized side, so on the binary side. And this is the part where MicroStream is become more and more a database, I would say. And in the end, I would say it's an in-memory database with the idea to keep most of the data in memory, except, of course, the lazy parts of the graph. So, as I said, it is possible to define lazy parts in your object graph to keep huge data on the hard disk and only have the important data which is needed in a high performance in memory. We don't need any data mapping. That's also important. We don't have any annotations and something like that, just pure POJOs. So just take the POJOs as they are. That is totally enough. Okay, as I said, we start with a small example project, and the first step to take part is, let me share the link to that project, so you can see the GitHub link in the chat. It's a small car exercise, and it's a Micronaut project. So that means feel free to check out the project itself and add it to your IDE, and then we can code along in that project together. So I think the first branch, or the important branch, is the branch which is called Start Exercise Here. That is the branch where we want to start. And the master branch is the finalized branch. So you will find all the implementations are already done in the master branch. And especially for the exercise, we can say, okay, start the exercise here. Okay, we have one question. Can we tune the frequency for offloading the data to storage or do so in chunks or in partition? Does the framework provide means for it? I hope I get it right. So does that mean the frequency of storing the data or offloading the data? So basically there is an offloading mechanism in the framework, which is, I think, basically 15 minutes after objects which are lazy loaded will be offloaded after 15 minutes. Is that what you mean?
Yeah, so can we override that?
Yeah, you are able to override that. That's definitely. So it's part of the lazy topics for today. So we talk about that for today. What about Quarkus support? Another question. I think there is. So I knew that my colleagues are working on a Quarkus support. I think it's part of the version 8, which is upcoming now or in a few days. I have to double check that. So let me take a note. But I'm pretty sure it's supported with Quarkus.
And one other thing, besides time-based, retention in memory and offloading to the storage, is there like an override that say takes the amount of objects stored or what is in the memory, or as opposed to time as being the effective limit at which we keep objects in the memory and offload them to the storage?
Okay. So I think it depends a little bit on your object model. So in some you have to take care about your object graph model, and especially what type of collections you use to define lazy parts of your object graph, which are staying on the hard disk. So maybe it is more clear when we wait till the lazy topics. Then maybe we can talk about this a little bit in deep. Or so I think let's wait for the lazy part of the training.
Okay.
For the lazy loading part of the training. Okay, so I shared the GitHub link, and as I said, it's a Micronaut project, and to start a Micronaut application, this is quite easy. In my IDE, I just have to use the application class here, and the only thing you have to do is to start that as a normal Java application, and then the Micronaut application starts automatically. There is one important thing you have to know, especially for Micronaut, you have to enable the annotation processing of your IDE. So that means within Eclipse, in the Maven section, you will find the annotation processing here. And in my part, it's on experimental. That's totally okay. But you have to enable annotation processing within your IDE. Then you will be able to start it. And basically, the server starts on in my example here on localhost :8070. But you can change this by adding some additional code. Oh, just a second, that's the wrong one. By adding some additional code to the open with the text editor to the application.yaml file. There is that important part. You can change this by adding a server and a port, and let's say 8070, for example. When you check out the project, it's empty on your side, so the project will start on 8080. But in some parts or in some cases, that is it's blocked by another application on your PC. So just to ensure that you are able to change the port, add server and port, and say, and yeah, these are, it's not tabs, these are blanks. So, and then it will start. Just try it out. When you check out the project and try to start it, there is no code in it. So especially on the, let's say, on the branch start exercise here. Let me just also switch to the start exercise here. Okay, here we are. So, okay, that's the application class, and this is again the wrong one. So open with text editor. Here you can see the server here. Okay, let's go through the project a little bit. Let me explain the project a little bit for you. So we have one package which is called storage, and this is where the database class, or I think the space is to initialize the storage of MicroStream. It's the DB class. It's empty because, yeah, it's an exercise. You should add your code to initialize a MicroStream storage. And then we have 3 different domain classes. We have a company, we have a car, and we have brands. And in our case, the company class is the root entity, I would say. So that means that's the root. Just to remind you, with MicroStream, we need one root entity. Could be a business domain object, for example, but it could also be a normal Java class where all the collections are in it. And in that case, the company is our root object. So we have a string name, and also that means that we are able to store one company in that application. But this company consists of many different brands and also many different cars. Let's step into the cars. We only have a name of the model and the brand, and we have the brand itself, and it only has a name. That's all for the domain objects. Only some small, straightforward objects, domain objects. Then, and these domain objects are finished, so you don't have to add code to that domain objects. Now let's get to the controller classes, and these controller classes are more important. Let's start on the brand controller. That's the easiest one, I would say. We need some code to get back all the brands of MicroStream or of the storage. So you have to add code here. And we have another method to insert a brand. And yeah, I think the important part is the MicroStream part. It's not important to do all that null checks or something like that. Just add a new brand to the storage. And we have the same on the car controller side. We have a list cars. Then we have some methods, get cars by model, for example, or get cars by brand. We have a clear cars and an insert. And I think that's all. That's the project itself. So let's say I will give you around, yeah, let's say 20 minutes should be enough to do the first important steps with MicroStream, and then we will do that together. So then I will do the coding here in my project. Any questions so far? So to summarize that, you have to fill the DB class and the 2 controller classes, and that's all you have to do. In the DB class, you should initialize the storage. You should create the storage manager. You should initialize the root of the root of the storage, and after that you can use the controller classes to get access to the storage and to add some brands and to add some cars in the end. Okay, some questions from your side? As I said, around 20 minutes. Let's say I will start to do, so we start to do that together on 10:45, I would say. these are around 20 minutes. I would say that's enough to initialize MicroStream and do some small implementations to the controller classes. Okay, so let's go.
So which branch? Oh, okay. So it's the start exercise here branch that we should be pulling, right?
Yeah, start exercise here. That is the branch you can start the exercise, right?
All right. Thanks.
This is like Spring H2, right? I'm not sure about that. So I know H2, but H2 it's basically a relational database, I would say. And I think that's totally different to a relational database. So MicroStream is different. But it's also a way to have an embedded storage. That's right. So it could be an embedded storage, yeah, like an H2. But the technology behind the scenes is totally different. So I think the basic idea behind MicroStream is to have the data in the RAM as an in-memory object model, I would say. And it would be great to change that model directly in the RAM and then say, okay, synchronize it to the stored or to the part on the hard disk, for example, or on AWS S3, for example. So that's the idea. Just to save an object graph as it is. So without any object relational modeling and something like that. Hello together for all the late attendees of the advanced training. We are at the moment, we are doing an exercise at the moment till 10:45 CST. So if you want to code along the exercise, you can find so I will post, or I will share the GitHub link again in the chat. So this is the GitHub link to the project itself. You can start on the branch, start exercise here. And you have to add some code to the DB class, which is empty at the moment, especially on the start exercise here branch. And then you have to do some smaller implementations on the controller classes, brand controller, car controller. The domain classes or the domain objects are already in place and they are good to go. You just have to fill the DB class to initialize the storage and to do the implementation on the controller side. And to Habib, I never used DerbyDB. Is DerbyDB also a relational database, or let me just check this. I've heard of DerbyDB, but I never used it. So I would say, especially with the relational databases, it's I think that the base problem is the object relational mapping. You will need to use Hibernate all the time. You have to do the mapping and the conversion of the data, and that is I think that's not the fastest way to handle data, I would say. Car insert. That's but it's so let's talk about directly about that car controller here. So especially here, the data transfer object, it's the car itself, but normally you will get the DTO, but in that case you can use the car as it is. So the transfer object contains the information. You don't have to take care about the JSON part of the application, just use the object as it is. A small tip, just use the DTO and check if there is a car, or let's say, you have to check if the brand is available, or maybe you want to create a new brand and then store the car itself. Yeah, and again, back to the relational databases, the overhead of that databases are so quite high, especially with Hibernate, and you have to know so a lot amount of stuff you have to know. And yeah. And I would say it's the same on any other technology like Redis or some other databases, NoSQL database especially. It's quite the same. You have to split up your object graph in certain ways. It depends on the database itself, and then you have to do a mapping again. And yeah, that makes things complicated. And just keep it easy. Just store the object graph as it is. That's the idea behind MicroStream, without any mapping or something like that. And I used, in fact, I used JSON, especially by insert car. You can see that here. Oh. What's wrong with my? Let me just close all tabs. Okay, here it is. So now I can share you. So this is the JSON part of the call itself. So this is the JSON for the car, and this is an example JSON for the brand if you want to test it. So 2 minutes left. Okay, so it's 45 now. I think let's do this together. Let's code along together. Just a second. Okay, here we are. So we are we start on the DB class, and for those of you who work with MicroStream for the first time, of course we need some dependencies in. Let me just share the POM XML. So these two dependencies are the most important ones, especially for that exercise. It's the first one, it's the storage itself. So it's the main part of the storage. And if you want to do some more configuration stuff, it's not part of that, but you will need this one. So as I said, these two dependencies are the most important ones when you start with MicroStream. The version 7.1 is at the moment is the current version, but in during the next few days there is version 8 is upcoming with some more features in it and stuff like that. But for version 8, you have to read the patch notes for that. Okay, so let's jump back to the DB class. And as I said, we need to initialize the embedded storage manager. So that means, let's say, public static. Come on, so public static embedded storage manager, and it is that one, embedded storage manager, and let's call it storage manager. That's it. So we need an embedded storage manager as a static reference. So whenever we need that storage manager to store something, then we will call db.storage manager and then store something like that. So we need the static reference. And then we have to initialize the root of our storage. And for that, we say public final static company. Let's call it root, and let's say equals new company. These are the two most important objects we need. So we need the storage manager and we need the root, and we use the static block to initialize both objects. And there are many different ways to do that. And one way is, and I would say the most popular way, is the builder pattern. And for that, we say, okay, let's use this. Let's use the embedded storage configuration object. Let's call the builder. And then let's say, let's create an embedded storage foundation. So, and then I would say that's always the same way to do. We need a configuration. Out of that configuration, we create a foundation. And based on that foundation, we create the embedded storage manager. And there are two different methods for that. One is to hand over the root directly, and we do so. So we add the root. And at the end, it's important to start the storage. So that means, let's keep it like this. So that's the best way to format. So like this. Really straightforward. So that means we use the builder pattern. So we create, we use the configuration object. We create an embedded storage foundation. Then we create the manager and hand over the root object we initialized here. And then we say, start the storage. That's all. Whenever we access that class, the storage manager is initialized, and whenever we want to have access to the storage, we have to go to the storage manager, or when we want to access the data itself, then we call the root object. And that's all we need on the DB class. Any questions so far?
How this code will gonna know that it is related to storage manager?
Can you please repeat this? Please?
So my first comment would be, this is not a builder pattern, because if we discuss within the programming community, builder pattern is something you get a builder and then you build something. And then if you want to start your thing, you can start it. Now, calling a start object on a builder pattern is kind of, seems like it is kind of termination of the builder itself. Is it creating a object or what it is doing? That is
on the first access, if you want to access, whenever you access this class for the first time to get the root or to get the storage manager, then MicroStream will start it. It started in the background.
Okay, so now how this code is related to storage manager object, because we haven't assigned anything to the storage manager. How it is assigning value to storage?
It's assigned by the company itself. So you see, the company object is the root, and the company domain class in that contains a list of brands and also contains cars. And that's the way how it is assigned. It's assigned by the object graph itself. It's like a tree. So, and this is what I said. A company could be a business domain class, in like on this example, it's a company, but it could also a normal Java class, like a class like named root, doesn't matter. And this class contains all the lists and all the structure which should be stored to MicroStream, and it's bind by the root object itself.
I think the question is about the storage manager, the line 10.
Okay.
Still null.
Ah, okay, I see. There is something missing. We have to assign it, right? So we have to say storage manager equals this. Is that what you mean? I forgot to assign this.
Okay.
Sorry for that. So I missed the part to assign this. No, I would not say that it's a common practice. It's one way to do that. It's totally up to you. I would say it depends on your structure in your code. I think the important part is you need the storage manager. You have to call a start. You have to ensure that there is only one object or is only one instance of a storage manager. But it's totally up to you. In this case, it's just an example to initialize this in that way. But yeah, it's an embedded storage. You can do whatever you want, I would say. You have to ensure that it's a static instance and only one storage manager is available. But it's also possible to have multiple storage managers in one project. That's also possible. Okay, so let's move on to the brand controller. Let's start with this one because it's
from my understanding, we need to perhaps write our own wrapper to initialize it at the start in Bootstrap. Okay.
You don't have to initialize it at the beginning. It starts automatically when you enter the first time your root object, then it automatically starts the storage itself. But let's have a look to that later. So you will see that how it works. So let's go on to the brand controller, and let's start with the get brands method. And now let's load all the brands we have. And the only thing we have to do is we have to say, okay, db.root that's the way to step into the object graph, and then say dot get brands. That's all we have to do. And with that call, MicroStream starts up automatically. So there is another question: how do I declare a root for totally independent entity models? I don't know if I get it right. So we want to have independent object models in one, or you want to have multiple roots. Is that right? So let's say, let's have a look to that company object again. So let's say, okay, in that part, we are only able to store one company, right? So that's also the reason why we have the name here. And this company has many cars and brands and so on. So what about if you want to have multiple companies in our object model? Then I would change this class to, yeah, let's call it root for example. And then we have a list of companies, companies in it. Company, for example. Then we have a list, and these we would not need this anymore because these lists and these collections are part of the company. So we would not need this anymore. So then we have a list of companies. But yeah, let's see that more detail later on. So in this case, we have one company. The root of a relational model would then be the database itself. Yeah, it's the entry object, I would say, of the object graph. So each graph has a root node, and the root node is the entry point to the data itself. So whenever you need to know something about your data, you have to go through the root object. And that's also the part we did here in the brand controller. We want to see all brands. Then I have to go to the root. And in our case, the root is our company. And then I can say, give me all the brands of my database. And that's the reason why I did it like this: db.root get brands. Okay, let's move on to insert a brand. And for that, I just have to check if there is a brand with a name already in place. So let's say db.root.get brands. And let's use the Streams API to find and maybe existing brand with the same name. So let's say stream.filter. Let's call it brand. And then let's say brand.getName. Sorry, brand.getName dot equals case DTO, data transfer object get name. And let's say dot find first. So we get an optional back from that. So let me assign this to a new local variable. So in this line, I check if there is a brand in my storage with the same name. And if this is not the case, so let's say find first dot is present. So if there is no object in place, Then we create a new brand object. So let's say new brand. Brand. So let's say brand.setName. We could also use a constructor for this, but let's do it like this, set the name. And that's it. That's all we have to do. So now the object is initialized, and then we have to store the object. And now that is really important. To store the object, the first step is to add the brand object to the collection which contains all the brands. So that means, that means a db.root. So let's enter the root, then say get brands, and then we say add this brand. Now our new created brand is part of the collection, and then we have to store this collection, and then we say, and for that reason we say db dot, let's go to the storage manager, let's say store. And now it's important, if you want to store an object, you have to store the object or the object which has changed. So that means in our example, we added the brand, we added the new brand to a collection, and that means we changed the collection itself. So there are many different explanations about that. So you have to store the owner of an object, or you have to store the reference holder of the object, or simply you have to store the object which has changed. And in that case, we changed the collection itself. And therefore, we say db root.get brands, because we changed the collection itself. And that's it. We have to do some return stuff. Let's say let's return the HTTP response. And we do the same down here. So that's the case when there is a brand already in place, then we get the HTTP response not allowed. So let's summarize that. This is the way to access the brands or access the root. Give me a list of brands. This is really straightforward and easy, I would say. And when we want to insert a brand, just use it like you all the time use it in your Java projects. Check if there is a brand already in place. If not, create a new brand object, set the name, really straightforward. And this is the special thing. So we have to add the brand to the collection of brands. And after that, we have to say, okay, DB storage manager store. And this is the way we synchronize the RAM with the serialized part of the storage. Then we say, okay, DB storage manager dot store. And then I say DB root get brands, because I changed the brands collection. That's it.
I have two questions here.
Mm-hmm.
First, can we store DTO direct without creating new brand object, because they are same?
This one?
Yep.
Yeah, you're right. Normally, this is what I said at the beginning. Normally, I would use a special object for a DTO, because in most of the time a transfer object is not the same object as the domain object in the application. But in this small example, I did this. But you are right; it's the same. We could also use this one directly.
Okay. And my other question is, so if I want to put some kind of lock to make it thread safe.
Okay.
So do I have to use normal Java, or I can get lock on storage manager somehow and do some stuff?
If you want to have a lock, you have to do some Java mechanisms for that. You can use synchronized or some concurrent collections or something like that. But let's talk about that a little later. There is a part of the concurrency part of the training. I will get deeper into that with some logging mechanisms and so on.
So is there like a data source library, or do we need to implement it ourselves?
What do you mean with a data source library?
Okay, it's so say that we have the database instance, and we need to come in to actually do multiple inserts, right? So normally for the concurrency, for other, okay, think something like the Hikari connection pool that we generally couple with JPA or Hibernate, etc., which actually do the synchronization under wraps. So is there like a group of classes for that, or do we directly need to do, you know, thread runnable, synchronize, etc., wrap this into thread runnable?
So I would say you will not need this anymore. So with MicroStream, you have to forget all that different database stuff, you know, of Hibernate and servers like that. It's just as easy as it is. There are some special things you have to know, but the way working with MicroStream is totally different. You have to keep in mind that all the persons which are using, for example, this car exercise at the end are working on one object graph. So that means the object graph becomes more like a cache, and everyone is working on that cache. And when you change the cache, everyone will notice that because he's working on the same. This is why the concurrency stuff is important, especially with MicroStream. But that's also the part where MicroStream is such a great high performance database. But it's totally different. It's more. It's not yeah. It's really different to other databases. I don't know if that helps you, but yeah, I think let's move on. I think the further topics will clarify a lot in the end.
Okay.
Okay, so yeah, let's move on to the car controller. And within the car controller, it's mostly the same. A list of cars. We already did that with the brands. It's the same. Let's call the DB class, let's say root, and let's say get cars. That's all we need here. Let's say cars by model. This is also an important thing because a lot of people ask us, okay, how to find the data, how to search for it. What about structured query language, SQL or something like that? And we say, okay, it's an object model. Just use your Streams API, which is available from Java 8. And we use that in that case. So let's say db dot, let's say storage manager. No, not the storage manager. Let's go to the root and then say get cars. And as we say by model, and here we have the string, which is handover. So get cars dot stream dot filter. We could also use the parallel stream in that part. Let's say filter. Then let's say this is the car. Let's call it car. So car dot get by model. We said get model dot equals. Well, let's do equals ignore case model, and then let's say dot collectors. Where is it? Let's do it like this. Dot collect. No. Now I'm out. So collectors dot to list. Okay, that's it. So let me just, let's say, stream, filter, collect. And that's it. That should do the trick. Okay, what about get cars by brand? I would say it's basically the same. And that's the reason why I just copy paste this from an example. So db.root get cars, stream filter. So then get brand, get name, and then it's, yeah, it's kind of like, it's the same. Equal ignore case brand. That's the same. So how about clear cars? How to delete something? The annotation for the car controller is cars. Clear cars. So let's say db root dot get cars dot clear. So we have to clear the list of the collection of cars. And then we are able to store this. Let's say db dot storage manager dot store. And it's important to know, okay, what has changed in the storage? It's the collection which has changed. And that means we have to store the collection. So let's say db.root get cars. That's all we have to do. So let's return an HTTP response again. I just copy paste this. And that's it. And last but not least, let's talk about the insert. And I just copy paste the first part of the method. So as I said, we have to check if there is a brand already in place. So I hand over a car data transfer object, and this car contains a string or contains a brand as a string. And I have to check if the brand is already available or not. And if the brand is present, so that means if it's a valid brand, then I have to get it. So, and in that case, I say, okay, optional brand dot get. So if a brand is in place, and now we have to create a new car. Or we could also use the data transfer object car in that case, but normally you have to do some mapping stuff here. And that's why I say, okay, car dot set brand. Oh, sorry, car dot set brand. Let's do the brand here. And then we have to say car dot set model. And for that, I say dto.getModel. Okay, so now we have the car object, and we have to add the car, db.root get cars, and say add car. And the same again to store that, storage manager.store. We changed the list of cars, and that's why we have to store the list itself. So get cars. Because the list is the reference holder, it holds the reference. And that's also a question all the time, how to get all these objects together. So normally in relational databases, you would have something like a foreign key or a primary key, and the car is binded to the brand, especially here, with a foreign key and a binary key, and the brand is stored in a separated list of brands or in a table, and cars are stored in a separated table. I think it's the same like here. You can see we have a list of brands and we have a list of cars, but to be honest, we would not need this list of brands because each car has its own brand included. So, but the problem is, what if we delete the last BMW, for example? So let's say we have hundreds of cars in it, but there is only one car which has the brand BMW. And when we delete the last car with that brand, we will lose the brand also. That means whenever we want to have a combo box, for example, or a list of available brands, for example, we need a second list of brands to fill combo boxes and something like that. But normally with MicroStream, we wouldn't need that brands collection. We do this especially for our business logic. So to have brands to fill combo boxes or to and the reference of the brand here is the same reference which is used in the car itself. So therefore it's this one. I search for the right brand and I use the same object reference here and I edit it directly to the car itself. And this is where the object is bind together to the brand. Yeah, it's Java. Yeah, it's a normal Java object-oriented programming. So this is how it works. So I stored it. Let's say I need to return the car and I make it, in this case, I make it the easy way. Let's say return car. Then we have the, and in that case, say return null. Yeah, doesn't matter. So it's just an example. Okay, let's check if this is working as expected. So three different things we did. So we have the DB class with the storage manager, with the root object. And just to remind you, you have to hand over the root and you have to start. This is where the storage comes together with the object model or with the object graph. And then we have, we did the implementation of the brand controller and the car controller. And yeah, in my example, just let me switch the branch to ensure that it's working properly. So let's move on to the master. Let's discard everything. So it's the same code, I would say, but yeah, you know, live coding is always a mess. Let me start the application itself. So run as Java application. Okay, it's running on localhost 8070. And let's have a look to the to my Postman. So first I have to create a brand, and in that case I use the post brands insert, and this is the JSON part. Let's send this, and we will get a bad request. So we have to change 8070. That's, I think that's the problem. Internal server error. Insert brand. What is wrong? Oh. Okay. So, okay. So let's do it again. So I will you explain explain that later. So there was a storage already in place, and that's why I get that result. Okay, so now we get 200. Okay, so I created a Mercedes, and I will also create a BMW, for example. That's also a 200. We can check if the brands are in place. So let's get back all the brands. Here we have that. These are the brands. Let's do insert a car. We have model 330 and then a BMW should be the right brand. Let's add this. Oh, we need to use 70. Okay, it's inserted. Let's add another one. 220. No. Let's that doesn't matter. This one, for example. Okay, and let's list the cars again. All cars, yes. Yeah, we have to change this. And here we have the cars. Let's start the application again. So to see if it's really stored in the end. Run as Java application. And just call cars. And here they are. And as you see, I just called the collection of all cars, and in the background, the MicroStream storage initialized automatically. But where is the data stored now? That's I think that's the biggest question. Where is the data now, or where can we find the data itself? So in the default configuration of MicroStream, it stores the data directly to the project itself. That means when we refresh the project itself, you will find a storage package. So let's have a look to that storage package. So show in System Explorer. So here it is. This is how the storage looks like. So we have a channel 0 package with the channel file and a transaction file. And this transaction file is an internally transaction file, especially for MicroStream. The channel file is where the data is stored. It's, as I said, it's a binary format. We are not able to read that. And there is another important file which is called persistence type dictionary. This is where all the different types of MicroStream are stored. We will have a look at this later, but this is the basic structure of the storage itself. And as I said, it's directly stored within the project. As long as we keep it in the default configuration, it will be stored there. But there are a lot more different configurations possible to store this on different locations. For example, AWS S3 or any other place on the hard disk or Redis or something like that. Okay, what about you? Could you start the project itself? Does it work on your side? Are there any problems with Micronaut or something like that? Any questions from your side? Feel free to ask. We have enough time for that. Okay. So okay, some other people always ask why I use Micronaut. Especially for those examples, I need a way to enter data, to load data and see the results and something like that. And normally, you could use a UI for that. But I think it's easier to use REST endpoints to see the result in the end, and that's why I'm using Micronaut. It's much easier to use, I would say. And you want to see the application YAML again. It's do it this way. Open text editor. So basically, you can skip this. So normally, in your case, it should look like this. Then Micronaut will start on localhost 8080 basically. But in some, maybe it's blocked for some reason, then you can change the port if you use servers colon and port colon 8070. It's just in case you have to switch the port. And it's also important to say you have to enable the annotation processing within your IDE. And normally you will find that within your Maven, on the Maven configuration, annotation processing, and in my case, it's on experimental, and that's enough. Okay, further questions from your side? Is there a Postman file to import? That's a good idea. That's a good question. Not for this example. I think the only so I only did different posts and gets and deletes on that example. All the other examples will only have get requests, and you can do this within your browser. For example, you can also use the browser to get all cars. For example, just say localhost 8070 slash and then cars, I guess, then and list on only cars, right? So yeah, you will also get the result like this. I've never exported the Postman file, but maybe you can. Is this possible to just copy paste some? And I've never done this before, so if you know how to do it, I can share it with you. I try to find a solution during a break. So give me just a few minutes within the break, then I can share the scripts for Postman. Okay. So let's move on with the first topic for today. This was the warm-up project. I think that's important. Most of you are on evaluation with MicroStream, and let's have a look on the different types of configuration. So how to configure the storage itself. I prepared a small presentation for that, and advanced configuration. So let's start here. So yeah, so we have, oh, there is another question. There should be a menu option export on the collection 3-point menu. Okay, I tried to find this during the break. Thank you. I'm sure I will find it. Okay, this is one example what we can configure. So all the files we have seen, the storage directory itself, the channel directory prefix, the data file prefix, everything can be configured. And especially when we have a look to the documentation of MicroStream, so here we are, there is one topic which is called configuration, and you will find tons of different possibilities of the properties of MicroStream itself. I think the most important ones are the storage directory. You can define which URL path on the hard disk you want to store the data. You can choose a different file system. So especially when we use AWS S3, for example, as a storage, then we use a storage file system. a backup directory. We talk about that backup directory later on. So how to handle backup. We have a possibility to add channel count. We also talk about that later. So as you see here, this is also maybe an important one for you, the housekeeping interval. We also talk about that later on. As you see, there is a lot of different possibilities to configure the storage itself, and also the different possibilities to initialize a storage. This is the way we used it before, the builder pattern, the storage directory in user home, for example, as I said, set backup directory, set channel count, and so on. We do this also directly in the IDE. But as I said, you find all the different possibilities to configure also in the documentation. But there are some special configuration, and especially on the advanced training, you have to know about this. And therefore, let's talk about the channels. So as I said, or as we have seen in the IDE, let me just go to back to the IDE. So let's have a look to the System Explorer again, to the target folder. Oh no, let's use the storage file. So this is one, we used one channel in that example, but it's possible to have multiple channels here, and that increases the amount of threads, the IO threads, to write down the data to the hard disk. And this is managed by MicroStream internally. That means must be N2, that's for sure. So you could have 2 channels, or 4, or 8, or 16, something like that. And I would recommend to have the half channels. I think a good way to use it is to have a channel count of 2. I think that's I normally have something between 1 and 4. I think 2 is totally fine. It could make sense to have more than 2, especially when you want to write down binary files, for example, or when you want to write many huge binary files. It could be helpful to have more than 1 IO thread to store it to the hard disk. But normally half the cores of your CPU should be totally fine. So let's say if you have 4 cores of your CPU, then it makes sense to have 2 channels, for example. But most of the time, you would not need to adjust the amount of channel. I think it's important to know that there is the possibility, and it will increase the performance of MicroStream, especially when you want to store binary data. Then the storage channel makes sense to increase the channels. But when you use MicroStream as a normal storage, I think 1 or 2 channels are totally enough. I think that's important to know, that there are channels which can be changed, or the amount of channels can be changed. But it's also important to know that you will not be able to change the channel count after initialize the storage. So that means when you start with 2 channels, you have to stay within 2 channels. And when you want to move to 4 or maybe 8, like that, you have to migrate the storage. That means just create another storage manager within your project, copy all the data to the new storage and store it, and that's it. So you have to migrate the storage. But let's have a look to the storage channels also later again. Another point is the housekeeping. You have to know that every time you change data or you change an object, this object will be added or appended to the end of the binary file. So that means let's do five changes, for example. So let's say we have one John Doe customer, and we have the object ID and this is maybe this could be the binary part. So whenever we change that, the object will be appended to the end of the binary file like this. But in the end, we will have, yeah, let's say duplicate object ID in our storage. And someone has to clean up the duplicates. And this is done by the housekeeping. And the housekeeping takes care to delete all the no longer needed files on the storage. And sometimes you have to increase the housekeeping, especially when you want, or when you add data in a high frequent way, because housekeeping needs process CPU time, and then it makes sense to increase. But we will do an example for that. So these are, I think, two important configurations, the channels and also the housekeeping. Let's have a look to that. Is there? Oh, okay. There are two additional informations. Yeah, it's kind of like a history of the data. Yeah, but MicroStream works as a history in the background, but you will not be able to see the history. Yeah, that's right. You can't use it, but it's like a history. Yeah, and you need someone to clean up the old objects. This is how you can adjust the housekeeping. There are two different properties. One is the housekeeping interval. Oh, come on. One is the housekeeping interval, and one is the housekeeping time budget. So yeah, that's also to see. It's kind of like a garbage collection, I would say. And this is the value that ensures how often does the housekeeping is running, and the time budget is the amount of CPU time to do housekeeping. Ooh, that's a good question. I've never used that Postgre MVC, right? So let's have a look.
So I have another question. During the housekeeping process,
yeah,
all the challenge will be used, or only one of them will be using and other would be free? So in other words, for example, if our storage is using 2 threads internally, both of them will be using for housekeeping, or one of them?
I'm not sure if I get it right. So can you repeat this, please? Sorry.
So for example, we have configured MicroStream to use 4 channels.
Okay.
It means 4 internal threads for storage, right?
Yeah, right. Yes.
So during the housekeeping phase, will it gonna use all 4 of them or only one of them?
So every channel has its own housekeeping. So we have 4 housekeeping threads for 4 channels, right? So every channel has its own housekeeping.
Okay, so this is kind of stop of the storage kind of thing.
So it's like, yeah, let's say it basically it is working in the background, and most of your time you don't have to take care about that. It's only important when you add data in a high frequent way. Then you have to ensure that because of appending the data again and again, you have to ensure that the storage on the hard disk does not grow to a huge storage in the end. So let's make an example. I think that will explain everything. So
and one more question: can we call this functionality programmatically?
You could do this also. Yeah, it's also possible to start the housekeeping. Yeah. but it's not necessary. It's not necessary to do that. So mostly it works totally fine. So no worries about that. But yeah, let's do an example of that. There is one project which is called, so let me just give you the link to that project. It is, a moment. And just put this one. So that is the link to the project. It's a configuration project, and there are several branches. There are several branches in it, and there is one branch which is called housekeeping example. So let's start on that branch. Just check out the project and move to the housekeeping example branch. And inside that project, you will find all the already known classes we need. We have an application class, we have a DB class, we have a data root. Especially the data root now, it's, yeah, let's say not a business object, it's just a Java object to keep all the lists of different objects. In that case, we have only a list of books in it. So that means the data root object is the root, and you can see that here we called the create embedded storage manager, and we added the root object, which is initialized above. So, and especially here, it's another. Let's talk about that later. So, okay, that is already configured. You don't have to do something. But one special thing is we have a MicroStream XML file, which is already in place here. And let's open that file. And you see here, we only created, we say, okay, the storage directory should be named data. And yeah, let's see what happened there. And you see the two properties for the housekeeping are not active at the moment. So let's see what happened now. There is one book controller in place, and as you see here, it is an in-stream which adds a lot of books in really high frequent way. Let's have a look what happens when we start this now without configuring the housekeeping. So let me just configuration here. I have just to double check if there is a storage already in place or not. So let's delete this existing storage, and then let's start the application. Okay, application is up and running on localhost 8080. So, and as I said, we are able to do this directly on the browser. Let's say localhost 8080, and then we call books/create. So now we have to do. So let's start this. Now see, okay, it's up and running. Now we have to check this is the data. Let's move to see show in System Explorer. Data channel. You see that? It increases all the time. Let's do it again. So let me just delete this. I think we have to be much faster. Let's delete that file. Okay. Start the application again. Run as Java application and call that create method again. Okay, let's go back to the storage. Let's go to it's the storage of the car exercise. Come on. But let's call it another one. So here we are. Okay, now we have 50 files. Let's call the method again. So you see, you will get more and more and more because the housekeeping does not have enough time to clean up the storage. And that's the reason why we get more and more data in the end. I think in a lot of cases, that wouldn't be a problem because after adding the data is over and you read the data, the housekeeping will clean up afterwards. So this is totally fine. But in some cases, it makes sense to increase the housekeeping a little bit. And let's do this. So let's stop the application and delete the data we have here. And let's say just increase the housekeeping. Let's say housekeeping every 400 milliseconds. And let's do this for 100 milliseconds. So let's have a look to the application. So let's open this one. That's okay. So let's say, okay, create. We will get the data folder. And now you see the housekeeping is running properly. So now it does not increase again and again because the housekeeping has enough time to clean up the storage during the stores in the end. Does that make sense to you? So I would say basically, normally you wouldn't have that much write requests to your storage. I think you will have double the double read request or 3 times more read requests than writes, but then you would not need to adjust the housekeeping interval, but it's basically possible. Okay. No more questions. Then let's move on to another example to see the channel configuration. And therefore, we have another branch within that project, which is called let's stop this. Just continue. Discard changes. Okay, let's stop the application itself. Okay, so we have I create it's the master branch, so we can do the coding together. So I created 3 different storage manager, and I will add another one. So let's add storage manager number 4. I also need a root _4, and let's try to initialize or let's do an example of the different ways to initialize a storage and to do some configurations also. Let's start on the builder storage, and just let me change the repository. Configurations done. So, okay, here we are. Okay, the builder storage. It's let's do this together with the storage number 3 equals, and we already did this. Let's call embedded storage configuration. Let's use the builder pattern, and let's add some more configuration. Let's say for example, the set storage directory, and we have seen these 2 methods, especially this one, set storage directory in user home. But in this case, I will say, okay, set storage directory, and let's call it a builder storage. Okay, another one, set backup directory. Let's add another one, and let's add this backup directory to the same package. Let's say builder storage. Builder storage slash backup. So that means a backup of the storage will automatically written to the backup folder. And yeah, let me explain the backup functionality a little bit more. It's part of the fundamentals training of MicroStream. MicroStream has two backup strategies, or two implemented or two embedded backup strategies. The one which is enabled by adding this configuration, it's kind of like a mirror. So that means whenever you write down data to the normal storage, a mirror or the same store will be written to a mirror, which is located then here. And this backup directory could also on a different store target. For example, you could have the storage on your hard disk, the ordinary storage, and then the mirror will be on an AWS S3, for example. That's totally up to you. So this is the first part, set backup directory. It's the mirror. Another part is a full backup. But let me just show you the full backup is here. You can find it in the documentation. So this is the continuous backup we talked about, set backup directory. It's, yeah, as I said, it's kind of like a mirror. And there is another method to back up the storage. It's a full backup, which is created with that small amount of code. I think important is to understand the full backup has to be a part of the MicroStream storage itself. It's not possible, or yeah, it is possible to just copy paste the part of the storage. That's possible, but you have to ensure that that the data is consistent at the moment you are copying the files, and therefore it makes more sense to use the full backup functionality within MicroStream, because then it works in a, let's say, in a queue, and to keep the storage consistent. So these are the two different backup functionalities. So, and we added it here. So set backup. Okay, let's jump back. So let's add some channels. Let's say set channel count 4. And based on that, let's create our storage foundation. And as I said, we should add the root also, set root, and here we use the root 3. And then we say start. And that's it. So I would recommend these type of initialization of the storage. There are many more possibilities to do some configuration stuff, channel count, channel directory. A lot of stuff is going on here. Housekeeping interval, this we had talked about before. You are able to set the housekeeping, the time budget, and so on. A lot of stuff can be configured here. And I would recommend to use this builder pattern to initialize the storage. There is another way to initialize. It's the shortest way, I would say.
I have one question regarding backup, continuous backup.
Mm-hmm.
Is it a transactional? For example, if immediate backup is not available, then the main write request will also gonna fail, or how it will gonna report back to user?
If the backup is not available, then it will be created. But whenever your main storage fails or something went wrong, you just it is transactional. So the backup directory contains only the last full written part. So that means the backup itself is consistent all the time, I would say.
Sorry, just to rephrase my question. Not available means, for example, we was using Amazon storage and internet was not available, but our NFS storage, local storage was available. So in this case, when someone try to write into the storage, what will gonna happen?
That is you will get an exception, definitely, but
so the whole write process will gonna fail.
Yeah, so in that case, when the backup directory is not available, you will get an exception, and you have to then you have to recover your application. I think MicroStream will go down when the backup is not able to write. You will get an exception, and the storage manager just shuts down the application itself.
Okay, thank you.
Yeah. It's not an automatic way. MicroStream, so you as a user, you have to take care about to restore from a backup. So it's not automatically made by MicroStream. So when something went wrong on the main storage, which is a quite rare situation, because when you write down data to the hard disk, what could go wrong basically? But if something went wrong, maybe, then I think the situation is such a strange situation. You have to take care, and you have to copy the backup directly back to the normal storage.
Okay, and while reading, so for example, we have 4 thread, which was reading the data. So can some of them read from the middle as well, from the backup? So some of them from the main storage and some of them from the backup storage. Is it possible, or they will gonna always read from the main storage?
Yeah, you have to use all of that from the backup. So you will not be able to copy separated channels, for example. That's not possible. You have to take the backup completely.
Okay.
It's not able to to have just a small backup parts. I say no, that's not possible. Yeah, you just copy the stuff from S3, for example, to local file system. Yeah, that's right. Okay, but we will see that when we start that, you will see the result in the end. These are the short storage, a short way to initialize MicroStream, embedded storage.start, and then hand over the root object and the URL of on the hard disk. And then we have the foundation storage, and this is I just copy paste this and do some explanations to that. This is I would say the long version, but it is also the most powerful version. So there are some configuration which has to be done on the foundation layer, for example, or on the configuration layer. And therefore, it's important to initialize a MicroStream in a long way, or in a more advanced way, I would say. This is also possible, and I would only recommend this when you want to use that deep customizations of MicroStream. Otherwise, you can use the builder pattern instead of using this one. But this is also part of the documentation. Whenever you need it, just you will find it in the docs of MicroStream. Okay. Any questions so far? Oh, I forgot the XML example. So, but I think we already talked about that. It's also possible to have the configuration within an XML file. We already seen that, and it's the case here. So I added a channel count and storage directory data, and this is a part which is used with Micronaut, and we load the resource and we create a configuration out of the XML file, and then we create the foundation, and that's it. Okay, so let me double check. We have storage manager 1, we have root 1, 2, 2, 3, 3. Okay, everything is in place. So let's start that stuff. Maybe I should change the branch. So let's move on to configurations done. Okay, it's quite the same. And there is one method which is called automatically on startup. So that means when we start the project, all the storages will be created. So let's say run as Java applications. And you can see this in the console. So that means the storage, this is the version of MicroStream, and then we see that the different storage manager are initialized, and you could also see that in your project when we do a refresh. You see all the different folders now. So we have the builder storage, and this is the storage with the backup in it. So as I said, we added 4 channels. So the channel count is 4. So we have 4 different channels for the storage itself. And then we added a backup channel, and you can see this is quite the same structure as the normal, and that's the Miro I've talked about. And whenever something went wrong with these files, you will be able to copy the backup directly back to the storage. So this is the builder storage. Then we have the data one. This is the I think that's the XML one with 4 channels. Then we have the foundation one, also with 4 channels and a backup. Let's double check this. Here you see set channel provider 4 channels, a backup setup. It's called backup directory, which is the same here, backup directory. Yeah, and that's how to configure. And we have the same is on the short storage. This is the shortest way to initialize MicroStream, and this one. So that here you can see it's also possible to have multiple storages in one project. In some parts that could make sense to have multiple storage manager. The memory footprint of a storage manager isn't that big, so it could make sense to have multiple ones if you want to have separated storages. Sometimes it makes sense, but it's totally up to you. So okay, so that's all regarding configuration, the different properties of MicroStream, and how to initialize MicroStream. Okay, any questions so far? Let me just double check the time. Okay, we are good to go. We have one question. Would it be possible to bootstrap a second node of my app from continuous backup? No, it's not possible. MicroStream is basically made for have one JVM to accessing the storage. It is because, as you know, on the background of the storage, the housekeeping stuff is running, and also the garbage collection stuff is running. And when you access an existing storage with 2 virtual machines, you will get in trouble because of these housekeeping stuff. It's not possible to access the storage.
So I would add something which might be helpful. So is it possible to have one Java application open storage with read only and other with write and read? Is it possible to do that?
No. Read. So it will be possible with the version which is upcoming next year, but not now.
So in future, it would be possible to start application with storage read-only mode.
So we thought about kind of like a read mode, so just to read the data, but at the moment this is not possible, not with that version.
Thank you.
So regarding my question about nodes, so my only option is like to run the full backup on the node 1 and then use this full backup to restore the second node.
So if the data structure is the same, this will be possible, yes.
Yes, because
So
I'm asking like my use case is that okay, I have multiple nodes which consume same events and project the state to some graph, a local graph. And when I spawn the new node, I want to have the state as soon as possible. I don't want to replay like millions of events. I just want the most up-to-date graph. It doesn't need to be the most newest one. But some recent version, and I can stream like the rest of the events to update it to the most current one.
So, but you have to stop the storage manager and start the storage manager again to access the new storage. So this is necessary. You have to restart the storage manager with the new storage in the end.
And there is an hack you can do. For example, you can have a REST endpoint where you can call the storage functionality to create full backup. And once you receive the response, you start your node, and then you can make sure that at that time I had a full backup. Because we can do the full backup by programmatically, right?
Not sure if I understand it right, but
so I'm saying, as you have shown the documentation, the second way of the backup. So this is the continuous backup, and the other way is the full backup.
So there is a full backup. Yes, right.
Yeah. So have a REST endpoint which will gonna create a full backup, and once the response come back, then you will gonna know that now this will be the up-to-date backup, and then you can start your second Amazon node with that backup.
Yeah, that's right. That's totally up to you. Yeah. It has to be the same data structure for sure. That's important, but yeah, that's possible, of course. It's a full functional storage, I would say.
So it's not possible with continuous backup because like the node which is live and using this backup is doing housekeeping and
that's right, because the Miro, I would say, is part of the running storage, and you should be careful to use this. We created another version which contains a replication. So the next upcoming versions of MicroStream will contains the replication. So then it will be able to replicate the storage to multiple other nodes. But this will be part of our cluster, and it will be available in the next versions. Yes.
Okay. Thank you very much.
Okay, I would say let's have a short break. Let's meet again at 12. Let's do 10 minutes. I would say it's enough. Let's meet again at 12:20 Central Standard Time. And then we go on with, oh, what is the next topic? Let me just check. So next topic. Yeah, let's talk about eager and lazy loading. I think that's the last topic before lunch. And then we start in the afternoon, we start with lazy loading. That's also an important topic. But now let's have a short break and see you then. Yeah, enjoy. Oh, okay. So I tried to find the solution for exporting the Postman stuff, but I was not able to do that. Maybe it's because the version I use, or maybe it's not available in the free version of Postman. Not sure about, but I tried to export. I couldn't find it on the 3 dots menu. Yeah, but I think it's not that important to have that. Okay, so let's talk about another short topic before lunch. So it's the transaction part, or the lazy or eager store part. And for that, let's have a look to another. Let's have a look to a short presentation just to get through that topic. So the basic store function, this is the normal thing. We already talked about that. Just create a book, and then we say, okay, db.root get books, add the book, and at the end we use the store manager to store it. That is really straightforward. We already used it. There is a we talked about the add a book. And here, what happened if we just change the release, for example, and add a new local date? In that case, we change the book, and then we have to store the book itself. I think that's easy to know. Okay, so let's move on. Let's talk about advanced store functions. So normally, when the default storing functionality of MicroStream is the lazy storing, and that means only reference instances are stored only if they have not been stored yet. If a reference instance has been stored previously, it's not stored again. So, and that means it is only, so let's say we have a customer, and the customer has a company in it. And when we hand over the customer object itself, only the customer will be stored, not the company. So if we have some changes in the company itself, these changes will not be stored. So that means the lazy storer only stores the upper object, not all the sub entities below. And it's different with the eager storing. The eager storing stores everything below the reference we hand over. So that means if you have a customer and a company, and the company itself has some more sub entities in it, and we say, okay, let's use the eager storer and hand over the customer, all the sub items below will also be stored. So, and that's the two different way to store an object. And it's also quite helpful to use these two eager and lazy storing strategies. Let's have a short look how to use or how to create an eager storer.
I need to just confirm one thing. Previously, you made a statement, if you want to store something, you need to store the parent object. So
that's right. Yeah.
So if company parent is customer, then don't we need to store customer?
So when you have some change, let's say a customer has a string like name, for example, and you change the name, then you have to store a customer. And with the lazy storer, only the customer entities will be stored. But let's say we have a company in it, and also a company has a name, and we change this name, and we use the lazy storer, and we hand over the customer, then only the customer will be stored.
So to rephrase your statement, it will only work if the primitive types change. If reference type change, it will not work. For example, if customer has an age of int, which is primitive, then it will work. But if it has age of type integer, then it will not gonna work.
No, that's different. So MicroStream knows what is a complex data type, like an integer, for example, and the differences between an own created object like a company. So it's different. So whenever you have a full integer within your company or within your customer, and you change that integer, it will also be stored because you change the whole reference. When you say, okay, add a new integer, then you change the whole reference instead of changing a value within that object, you know?
Okay, so just to rephrase, if we change the value inside the reference, then it will not gonna work. But if we change the reference, then it will work.
Yes, and it's because even when you have a big integer, let's say, so we have an integer object, and we say, yeah, let's imagine it's a field which is called the weight, for example, yeah, of a customer. Doesn't matter. So let's say set weight equals 80, for example, then the whole integer will change. The whole reference will change, and that is the reason why we change the customer itself. But let's say a customer dot get company dot set name, for example, then we change the company object itself, and therefore we need to change the company, not the customer, especially when you use the lazy storer.
Okay, thank you.
So, and but to create an eager storer, to store also the sub-entities of an entity, you can create an eager storer. Let's say db.storeManager create eager storer. And then we are able to use this eager storer, yeah, also for a kind like a transaction. So we can say, let's change some values of the books. Let's say book set price, and multiply the price in that case. And then we are able to say, okay, storer.store b, that means register the stored object. Just a second. So register the stored object within the storer, and after that we call storer.commit, and this is the point where the data goes to the hard disk in that case. So, and that brings us also to the possibilities to do some transaction stuff, because if something goes wrong during the time, we will be able to do a rollback, for example. So and you could also use this to create a lazy storer. That's also possible. It's not recommended to do this all the time, because as I said, or if you remember, all the data will be appended to the storage. So, and that means you should take care about to keep the amount of data appended as small as possible, for sure. So that means you should not store. So for example, let's say we have a root object and many sub objects inside, many collections inside, and so on. It will be possible to say, okay, let's create an eager storer and add the whole root to the storer, and then say store commit. That will work and will also store all the underlying sub entities. But yeah, that is that means that the whole root object will be added or will be appended to the binary storage in the end, and that makes no sense. So and for that, I would recommend not to use that eager storer all the time, but in some cases it could be quite helpful to have that eager storer, especially with some transaction or rollback mechanisms. But you could also create the lazy storer. What about rollback? So and transactions. So basically, as I said, MicroStream does not provide an explicit transaction. Every call to a store method is automatically an all or nothing operation. If the store call is successful, all data is written to the story. Otherwise, no data is persisted. Partially persisted data will be reverted. That means when the connection, for example, to an AWS S3 bucket is broken, let's say, then you only have half the data on the storage. It will be automatically repaired in combination with that transaction file and so on. That means it will be reverted. What about rollback? I already talked about that. But yeah, let's move on directly to the project. It makes more sense to see that within the code. First, let's talk about that eager storer. Here is an example again. Here you can see db.storage manager create an eager storer, and in that case we use the eager storer as a transaction, as I said, to change the price. I think it's not necessary to use an eager storer in that case, because in this case we changed the price. That means we changed the book itself, and it makes more sense in that to use the lazy storer. That this will do the trick, or this will do the same as the eager storer. The result will be the same. But yeah, I think that's important to use this structure for special transaction or something like that. One question: what about to do it like this? What if we use? Does it make sense to you to do it this way? To say storage manager tot.store B? We could also do it this way, right? So this could also be a solution.
Yeah, it will work, but it is not transactional. So if something breaks, for example, connection breakdown,
yeah,
the things which we have already sent, it will be there, but new will not be there.
So basically, you are right. Regarding the transactions, that's right. But let's say we don't care about transactions. So let's say, okay, if there something went wrong here, okay, the already changed objects are in place, and yeah, then the solution is possible basically. But you have to imagine that a store is a blocking operation, and yeah, the performance wouldn't be the best. So that's also a good point to say, okay, every store needs performance, and it will slow down your system when you use it in this way. It makes much more sense to use this because of performance, to have only one store in place and not every book you have changed, because it's a blocking procedure. Okay, let's go on with some rollback stuff. And as I said, there is no rollback functionality in place yet. There is one upcoming in version 8, but I prepared a small example for you, and it's the exception handling project. Let me just share the link with GitHub. Try to find it. Exception handling. Okay, here we are. That's the project. And this project is already in place here. Let's have a look to the rollback mechanism. So the important thing in that project is there is one method within the utils package, and it's called binary persistence reloader. And this is just a class you can copy paste to your project, and it will be available as a utils method within MicroStream in version 8, but not in version 7 yet. So that's why I prepared this class for you. So, but it will be totally the same. In version 8, you can use the utils method to do the rollback. And there are two different methods in it. It's the same like here. It's a reload flat method and a reload deep method. And you just have to hand over the object instance. And it takes care about to sync back the storage to your RAM, which is made in the controller class here. So let's have a look. So there are two different methods. One update book non-store. So that means I changed the RAM inside that method, but I didn't store it. And it's the same on the author class. So it's a little bit deeper because author is a sub-entity of book. And as you can see here, so I try to find a specific book by an ISBN. And then I say, okay, book, give me the author and give me the last name. And in that case, I changed the last name. So get author, set last name to John Travolta. And as you see, I didn't store it. So, and then we have two different methods here. The one is the rollback flat and the rollback deep. And here you can find the persistence, the binary persistence reloader. This is later on, it will be a utils class of MicroStream. And here we can hand over the persistence manager and it will reload the data. Just a moment, sorry. Okay. Yeah, you can see that here with that reloader, you have to hand over the persistence manager to the reloader, and then you can say reloader.reload flat, and then you have to hand over the book in case of an exception, or use the reload deep method in especially when you want to remove or revert some sub-entity fields. Let's try this. Let's start the application on the application class, run as Java application. So let's say, give it just a second, localhost books. There are, we don't need that data anymore. So, let's try to find some books. Okay, as you can see here, books are empty at the moment. Let's create some books. There is one method which creates some books. Let's have a look. Now you can see books are in place. And now let's change the name of this specific book, the start chamber. And there is also an author in it, which is called Roger Firks. Let's say books dot just the name change? No. Books controller. Update non-store. Yeah. Let's say books and then say update non-store. Okay, now we change the name of the book, the start chamber, to Java the Good Parts. Let's have a look if this is the case. Now you can see Java the Good Parts, but now that is a dangerous moment, I would say, because normally you wouldn't get any. Normally you would get an exception, of course, if something went wrong. But now you changed the graph in the background, but you didn't store it to the hard disk, and you can go along with that with the storage. You will not notice that the data isn't changed or isn't stored, I would say, until the next restart. Then, and therefore you have to add a proper exception handling. Now let's try to revert this. Let's call it a rollback flat, and let's check. And you see the data is rollback. We have one question: is there a trick to see the binary persistence reload a Java file? No, it's in the utils package here, and it's not yet a part of the MicroStream framework, but it will be on version 8. Okay, let's try the same on update non-store deep. You have to choose a different branch. Just use the rollback impl branch. Now the author has changed. Let's check. Now you can see this is the last name, or the wrong name, I would say. And let's do a rollback deep. And this will change back to fix. Okay, so this is the rollback mechanism and also the transaction things. You have to take care by yourself. It's not a built-in mechanism of MicroStream itself. Yeah, it's a thing you have to take care of, and I think it's easy to achieve that within the Java code. And yeah, basically that's the important part. Let's have a short look to the exception part.
So you didn't call flat endpoint. So I am assuming if you did call in author case, it wouldn't work. So what is the difference between flat and deep endpoints?
So flat means it's only the upper object which has changes. So in that case, book. So I changed the book. I changed fields of the book directly. In that case, the name of the book. And this is why I called it flat. So flat, it only restores the fields of the book itself. And the rollback deep mechanism restores all the entities and all the sub-entities also. So that means a book has an author, and also the author will be rollbacked. So that's the difference between flat and deep. It's like a deep copy or a flat copy. I think it's the same. Does that answer your question?
Yep, thank you.
Webbook, did you find the file in another branch? Great. Yeah, as I said, it will be available as a utils method in version 8. Yeah, I should do. That's a good point. I would say it's time to have lunch break now. So let's meet again at 1:30 p.m. Yeah, and then we start with the first very important topic, the lazy loading stuff. Okay, I would say enjoy the lunch and meet again at 1:30 CST. Enjoy. Okay, welcome back. So we are still 20 people, so that is really great. That means we are complete. I hope you had a tasty lunch and or dinner, depending on your time zone. Before we get into the lazy loading topic, as promised, I will hand over to Marcus Kett, our CEO. He will talk about a little bit about the roadmap and the plans for the next year. Marcus, are you there?
Sure.
It's your time.
Thanks, Christian. And hello, everybody. Thanks for joining our advanced training. I don't want to interrupt this string for too long, but I wanted to take the chance to say hi and to everybody and to make some announcements, because I think it's very interesting what's coming up next year. Only for 10 minutes, and then I will hand over again to Christian. So first of all, I have to try to share the screen. Now you should see my screen, hopefully.
Yes.
Okay, cool. It's challenging because normally I work with 2 screens. Now I have only the laptop, but no problem. So as you know, our vision was to create data storage specifically for Java, because all of these database systems out there, they're great, they're doing the job, but they're working differently to Java. And we wanted to build something that works and feels like Java, a storage function that feels like a storage function from the JDK, actually. And this is what we wanted to build with MicroStream, to be able to have object-oriented access to data, and super easy, super fast, and which fits seamlessly with the cloud and integrates seamlessly into the cloud. This was our vision, and then last year, or is it last year, we have open sourced it. Now we are integrated with here on many conferences. We are integrated with Project Helidon. So after we have open sourced it, the Helidon team at Oracle has integrated MicroStream into Project Helidon. Then our next step was to become integrated into the Micronaut framework, and so we are very happy about this beautiful integration with Micronaut. So great combination. And the next step is now, and the announcement is now that we have joined the Eclipse Foundation as a contribution member and we're also going to join the MicroProfile working group next year. So this is our plan. So we have we're not, I guess we should be already accepted. So we're sent the forms yesterday, and now we're already an Eclipse Foundation member. But why should we join Eclipse Foundation and the MicroProfile working group? It's because MicroStream is a great persistence for microservices. It can be, of course, used for monolithic applications as well. And because we have built it actually from the beginning for monolithic applications, because we started the project 10 years ago, almost 10 years ago, and not that much people were talking about microservices that time. But today we have the microservice architecture as a common architecture for enterprise applications, and MicroStream fits great as a persistence for microservices. And this is the reason why we believe we're the perfect persistence for microservices. And this is the reason why we want to contribute to the ecosystem of the microservice infrastructure world. And at MicroProfile, the standard for microservice frameworks is defined there. And so we should join the working group and create the standard together with other great vendors and contributors. But that's not all, and that's not the big story here. The bigger story actually is we have more. We have additional plans, not only joining a foundation. We also want to push the code, the entire MicroStream code. We donate the entire MicroStream code to the Eclipse Foundation. And we continue development MicroStream as an Eclipse project. So this is only a draft. You can see here only a draft. So names will be defined within the working group, but internally we call it Eclipse Stream. So MicroStream will become Eclipse Stream and we keep we continue development as a top level project. So this becomes the reference implementation. And the second thing is we're gonna start a working group, and we found a working group where we defined a standard specification similar to the JPA standard. So JPA standard is defines how object relational mapping works for Java and relational databases. And what we are doing is we follow the system prevalence pattern. The functional principle is very simple, which means we keep the objects in memory, we keep the system state in memory, and by creating snapshots, we persist the system state and write the system state on disk by creating snapshots. The functional principle is very simple. The framework is a little bit more complex. And now what we want to do is to create a standard and to create a specification together with other vendors or other members of this working group who are interested in defining that standard and creating this standard. With this standard, and it's also internal, the name is also internally because the name will be defined by the working group. We call it Java Micro Persistence API, similar to the Jakarta. Yes, we have here the first problem. We have to change it in Jakarta because it's Java is a trademark by Oracle, of course. So Jakarta Micro Persistence API, similar to the Jakarta Persistence API. This specification will define how the functional principle works, the functional principle of MicroStream, and then to allow other vendors also to build implementations. The first implementation will be, as I mentioned, Eclipse Stream. MicroStream becomes Eclipse Stream and the reference implementation. And we will continue development under the Eclipse umbrella. Then we join the MicroProfile working group, and the goal here is also to include the new standard into the MicroProfile standard. It's because if it becomes a standard within MicroProfile or under the MicroProfile umbrella, then the microservice framework vendors, they have to include the standard and the implementation into their frameworks. Helidon MP did it already, and Helidon SE is also an integration. But all the other vendors, then they have to implement MicroStream and to enable Java developers to use Eclipse Stream very easily. So secondly, we will continue MicroStream as a company as well. And it's because under the Eclipse Foundation and as a community project, as a foundation project, it sometimes might be a little bit, the development process might be a little bit slower. It's because of there are discussions, and so this might be the reason why we cannot move that fast forward as we do it in the last 10 years or so. So we continue our own implementation. We keep the name MicroStream, and we call it MicroStream Enterprise Edition. So under the MicroStream roof, we can proceed a little bit faster. And what we have learned in our commercial product, we can then also push again back to the Eclipse Foundation and to the Eclipse Stream project. So this is our goal. And yeah, perhaps we will see other vendors implementing MicroStream, and similar to the JPA standard where we have hybrid as an implementation, we will see other implementations like OpenJPA or Eclipse Link. Then we have other implementations for the JMP standard specification. On top of the core frameworks, Eclipse Stream and MicroStream Enterprise Edition, we will provide MicroStream Enterprise Cluster for creating distributed applications and microservices to run MicroStream as a cluster infrastructure. And with MicroStream Enterprise Edition, it will also be possible to create real big data applications, which means from 1 terabyte database storage or even bigger. Then we will have MicroStream Enterprise Cluster, which will work with Eclipse Stream implementation. It will work with MicroStream Enterprise Edition, and it will work with perhaps third-party vendor implementations. And because of MicroStream Cluster is not that super easy to implement. So if you have enough experience with cloud, perhaps it will be simple. We will say it's super simple, so I have no problems to implement it. If you have not that cloud experience, then we'll say, oh, this is effortful. And it's the reason why we going to introduce MicroStream Cloud to run MicroStream Enterprise Cluster by clicking only some 3 or 5 mouse clicks to set up Enterprise Cluster. And then we have the big picture. Then we have the standard under the Eclipse umbrella. We have a top level project, Eclipse Stream, which is a reference implementation. Then we have the commercial implementation, MicroStream, where we are able to proceed a little bit faster. We will have the cluster solution for distributed applications and cloud for very convenient installing, setting up, and maintaining MicroStream clusters. And hopefully becoming integrated into MicroProfile and becoming under the umbrella to grow faster in the community, to become more accepted as it is already today. So we're growing very fast. So we have our download rates. We have around 24x more downloads in comparison to last year when we have open source MicroStream. So it's really incredible. So we're growing, but with Eclipse, the strategy will grow even faster. All right. And by the way, of course, you were very early with MicroStream. So, and with the advanced training, you become very fast familiar with MicroStream, having the chance to become expert. And you're invited to join the working groups where we define the specification and very development, Eclipse stream, the reference implementation. So you're really invited to join us. One thing I like to add here, also internally, we are really talking about and discussing very often about memory consumption. And so, because we all the time talk about MicroStream turns your application into a high performance in-memory data processing monster, because we say, yeah, you have the chance to execute everything in memory, keep your data in memory, and to reach incredible fast query time. So we talk about microsecond query time, around 1000x faster than common SQL queries. And it's because we have data in memory. We keep data in memory. And to be able to keep data in memory, of course, we need memory. But also in our customers' projects, there is often the question, why do we need so much memory? Can we run MicroStream with also with less memory? And we have this lazy loading, so that fits really great in this training at this point, because Christian will introduce lazy loading in some minutes. Yes, you have lazy loading, so which means the pattern says, yeah, keep all the data in memory. But and if you have enough memory, you can do that, and you should do that. It's recommended, but it's not required. And it's because we have lazy loading. We don't have to keep the complete database in memory. You can run also small RAM instances with small RAM sizes. That's possible, and that's the great thing with MicroStream. But we talk about in-memory computing, and so you should have memory, and memory is not that fast. I'm sorry, memory is not that expensive today. If you believe memory is still too expensive, then I like to show you how you can save a lot of money, and this will allow you to buy some more memory to build super fast applications. And by the way, it's not only super fast, it's also much easier because of the system complexity is much lower. So it's much simpler to create database applications. And this is also a factor. So let's have a look on what I mean. So if you run microservices and applications in a cloud and you want to become cloud native, and by the way, what actually means cloud native? So there are several definitions. In my opinion, cloud native is if you use all these components provided by the cloud vendors. The native cloud functions like the blob stores, like AWS S3. If you use serverless like AWS Lambda, and all the cloud providers, they have their serverless computing platforms. So if you use this infrastructure, then you're cloud native. If not, Adam Bean, so a good friend and advisor of MicroStream, he said in our last internal workshop, hey guys, do not work and develop against the cloud. Use the cloud native functions. That will be cheaper, and you can integrate your applications seamlessly into the cloud. So if you want to go to the cloud, use the cloud features. And with MicroStream, you can do that. So if you build microservices and you use JPA, it's great, or NoSQL database, you can do that. But cloud native would mean you would need and use the relational databases as a service, and you can calculate it. If you run PostgreSQL as a service and you run it on a not that big machine, then you pay around 14K annually only for 250 megabyte database service. That's not cheap. And we don't talk about license fees. If you use AWS S3 and you store 250 gigabyte of data, you pay only $70 annually. So this is incredible cheaper in comparison to database as a service. With MicroStream, you are now able to persist your objects, any kind of object graph, any size, any complexity, store it directly into the cloud blob stores, and you pay almost nothing for your storage. And it's even more simple to create globally applications. Why? And it's because you don't have to care for a database cluster. You don't have to care for database data center replication, because AWS does it for you. So you can store in Frankfurt, Europe, and you can read in Los Angeles, USA. It's because AWS cares for data center replication. That's fantastic. So the only thing is you need AWS service, and with MicroStream you can use it. And here are the great advantages. You save a lot of money. And here is an example. Here's a real world example from our customer. Actually, they need 3 clusters. So an application cluster, because it's a distributed application, of course, we have an application cluster where we have multiple application nodes. They have a database cluster, database as a service, where we have 6 replicas, and in between there is a distributed cache cluster. 3 layers, 3 clusters, and with MicroStream today, they only need an application cluster, because with MicroStream Enterprise cluster, we can replicate the application or microservice nodes, and then we only need 1 cluster. We store data in AWS S3. No more database cluster required, no more cache cluster required. So we save a lot of money, and so now our customer is able to buy a little bit more memory to accelerate their applications or microservices and run bigger app machines. So 2 minutes, only 2 minutes. This is our process in general. So most developers get started with playing around with MicroStream, experimenting, and that's great, because we are developers. We have to experiment with new technologies. Then education. So you guys are already at the next level. You join the training. That's great. Then most developers start with a proof concept, and then starting implementing MicroStream, running MicroStream in production. Training is great, but we believe we should give you more support. And we have developed a concept that should give you the best possible support for software for Java projects on the planet. This is what we wanted to create and want to offer our developer community. And we start this in March or April, not for sure, but we call it the MicroStream Masterclass. This presentation is internally used only. It's not, we have not published this already. And this will be a mentoring program for developer teams for 3 months up to 1 year or even longer. How does this work? In some words, in a nutshell, it's because of we want to eliminate all of these challenges with new technologies. So developers don't know how technology works, so we're experimenting. We play around. We believe, I know everything about it. So, but you cannot be for sure that what you have implemented is really correct. This is the one thing. The other thing is most of our solutions, they work together with many other solutions. So we saw many projects where MicroStream is combined with microservice frameworks or other frameworks, and there are so many challenges. The teams sometimes have different opinions about the technology itself, about the architecture, or how to proceed in the project, and so on. So many challenges. You know, all of these have heard all the time, or you have the same challenges, of course. And now we wanted to provide you a coaching and a coaching program where we support you daily, if needed, or weekly by weekly mentors calls. And we're experts in MicroStream, of course, but we're not the experts in all technologies you need for creating microservice-based projects. And this is the reason why we now, this is draft only, so don't look at the pictures. But some of these guys have already agreed to be in. So we have a pool of experts where you can call on demand and they will support you. Like Adam Bean or Ottavio Santana. So we have Sven Rupert, we have many Java champions. We have AWS heroes. So for almost everything, you have questions, you have doubts, you have problems, you need a review. You can contact a specialist. And this is included in the MicroStream Masterclass for your entire team to support you through the complete development and implementation process, from the proof of concept until going public, until you launch and your application and run it in production. So we will introduce this next year. The roadmap is very simple. We only can support 20, perhaps 30 teams globally, because MicroStream is growing fast, but we're still a small company, and we want to provide the best possible support. This means we believe we are able to support 20 up to 30 companies, not more, next year. Start with an info call. We do a application process. We select the teams if this fits to the program. We have an intro call. We have a project analysis. Then we'll have a kickoff event where we introduce all these mentors. You can get in contact with them, and you can find out with which mentors you like to work together. And then the program starts with the weekly mentors call, and you can really call the mentors on demand anytime you need the mentors. There are additional workshops. The MicroStream education is included. All trainings are included. Developer support is included, and great other workshops That's not for sure, but I'm pretty sure that we will be able also to include direct contact to the developer teams of microservice frameworks like the Helidon team. So no promise here at this point, but I'm very sure that we can give you direct access to these fantastic teams. All right, that's it. These are our plans for open source and for the next year. Thank you very much. And again, thanks for joining our training. And yeah, ask Christian everything you like to know about MicroStream. He's one of our great experts. And at this point, also like to thank you, Christian, for the great job you did last year again, or this year again, with your cluster team and in our project. Thank you. And for participants, Merry Christmas and Happy New Year. Thanks.
So thank you, Marcus. Great introduction. And as always, CEOs talking much longer than promised. So that's always the same, but it enables me to bring more tea to support my voice. So
could you give me some more 5 minutes? Sorry about that.
Yeah, let's get straight into the lazy loading topic. And so I like that topic much because it leads always to great discussions with our customers. And yeah, let's get into it. Let's have a short view to the basics of MicroStream and how MicroStream basically works. Okay, so we want to talk about why do we need to store and load data in a lazy way. I want to talk a little bit about what data should be stored lazily and which data could stay in the memory, for example. We talk about how to use lazy references in code directly. And especially I want to talk about some best practices examples and what is the best fitting data structure within the lazy loading data. Also, another important topic is how to release lazy loaded data. There are two different possibilities to do that. Yes, okay. So the basic functionality of MicroStream is that it's an in-memory database framework. So that is also that is not only the reason why it's so fast and performance on, but it's one of it. So that means for best performance, the data has to be in the RAM, and I think that's quite clear. And in a lot of projects I've seen in the past that yeah, they use a basic relational database and they load data in a cache to have it in memory and to get access much faster than from a relational database. So, but in some cases, as you know, it's impossible to hold all the data inside the RAM, especially for binary data, for example. That's not possible to have everything in the RAM. And sometimes it's also quite unnecessary to hold the data inside the RAM. E.g., let's say we have some archive data, for example, or there are some logging data, historical data, and something like that. So we will not need to have that in the RAM. Okay.
Sorry to disturb you. Are you sharing some screen slides?
Oh, sorry. I forgot to share the screen. Okay, so let's move a little bit back. So, okay, these are the topics. And so this is what I'm talking about. So that's important to find a way to keep data on the hard disk or on the storage. And yeah. Okay, so the default behavior of MicroStream is that every data which is part of the database will be loaded on MicroStream startup. This is the basic behavior. So Whenever you have a list of customer, for example, this list will be loaded to the RAM directly after startup or after startup MicroStream. That means, for example, if you have 100 million objects in the storage, on startup, you will have 1 million objects in the RAM. And that becomes, I think that's a problem. And we have to take care about lazy references. That means, or let's call it lazy nodes, I would say. So that means we have an object model here on the left side, and we have some lazy stuff here. Oh, that is because the resolution, but I have to fix this. And in the end, the data model in the RAM looks like this. So that means we have 100 million objects in the storage, but we only have 500,000 in the RAM in the end. So because of lazy loading. So the question is when to use lazy loading. So basically, I would recommend always on binary data. So I think that's quite clear. I don't need all the binary data all the time in the RAM, especially when we are talking about the cloud. It's always, I would say, best practice to keep binary data on a special system. Let's talk about AWS S3, for example, or something like that. Keep the data out of the database. Store it on any file storage or something like that. That's much better than to have it in a database. So, but whenever you need it in the database, or please use lazy loading on binary data. How to do that? We're talking about that later. So, and we talk about blobs and documents and images and so on. Okay, always on huge collections. That's also important. Whenever we have collections with thousands or millions of objects in it, we have to think about lazy loading. But how exactly? Let's talk about that later. But the important thing is always on huge collections with less frequented data. As I said, logs and archive data and so on. So you should use lazy loading sometimes on collections with huge amount of sub-entities. That could also be a point which is quite interesting, because not only the one object on top, it's also possible to have, let's say, the company, for example, has a lot of sub-entities, let's say employees and whatever else. So, but the company object is part of two. Let's say we have a customer object and he's part of a company. And then it could be possible that you want to have a list of all customers, but the company itself should be loaded lazily. So then it makes sense to have a lazy references to the company, to have only the customers within the collection. That's the point. Or so basically, whenever you want, if performance isn't that important, especially because the data has to be loaded from the hard disk, or the amount of RAM is limited, and that's an interesting point. But let's see. Okay, so basically, how to use lazy loading, especially for binary data. Here we have two examples. The first example, I would say it's the easiest way to handle data in a lazy way. You just have to add a lazy wrapper like this, and then add it's a kind of like a lazy object, I would say. And this lazy object covers the original object, and in this case, it's a byte array. And in some cases, it makes more sense to add some descriptions or to add a name of the file you stored to the database. Then you could use the second approach here. In this case, we are using a hash map, which contains a string as the key. And I would say the string is the name of the file, for example, something like that. And in the value part is the same as above, to have a lazy reference with a byte array in it. And this could be one solution to handle binary data. So it's important to know that whenever you want to get the image out of the lazy object, you can use the get method to get the blob out of the lazy wrapper. And yeah, I think it's a much better approach to use a hash map instead of using a list. But yeah, this is up to you. You can so if you know that there are only 5 documents in it or only a few pictures, then it's also okay to store it in a normal list of byte collection like that. So because this is a single byte array. Okay, let's talk about huge collections. An example like this. So that is the easiest way to handle lazy data. So we have a lazy object here, and it wraps a list of books. And the way to define a lazy reference is this. So let's say lazy.reference, and then initialize the new array list of books. That's the easiest way. I would say best practice for most low and medium sized collections to be aware of maybe huge amount of sub items. So that's important. The next point, for streaming and filtering, you have to load the whole lazy collection at once. That's an interesting point. That's also the reason why I said for low and medium sized collections, because when you want to search within books, for example, then you have to load and unwrap the whole list of books. That means to search some books in it, you have to load the whole list. That's important to know. This could also be a nice approach to have a hash map with some lazy lists in it. This could help also a lot, especially for huge huge collections. That gives you the possibility to have an index, a self-defined index, I would say, in your key attribute. For example, the first 2 digits of the ISBN of books which are part of the list in the end. So that means whenever you search for a specific book, you don't have to unwrap all books at once, instead of searching for the first 2 digits of the ISBN and then move on to the list of books to unwrap only one collection of books. There is one question: what exactly is the amount of huge or medium collection? That's hard to answer, I would say. I would say it depends on how many fields are in your object, or how many fields does your object have, or how many objects are in the collection itself. I mean, it depends a little bit on what data types are. It's always best to have a lot of primitives in your object that decreases the amount of RAM or the amount of memory which is used by the object itself. Yeah, it depends on that much. So a lot of different factors, I would say. So yeah, it's hard to answer, but I think you have to try a best practice, or you have to try it, and you have to know, okay, your memory consumption, or you have to know the amount of memory you have in the end. But yeah, let's move a little bit. Let's move on. Maybe there are some more solutions I want to show you. What about releasing data? So there are 2 different possibilities or 2 strategies to release loaded data. It can be done manually or automatically. So whenever you want to offload, I would say, then you can use the lazy image.clear method. Whenever, you have this is the lazy reference, and then you can call clear, and this will, so I would say that this will release the data, but the garbage collection is important. in the end, the garbage collection clears the RAM, not this method. So that means that the data stays in the memory until the garbage collection clears it. Okay, that's the manual way. There is another way, an automatically approach. It's part of your DB class, and we will also have a look on this in practice. This is a lazy checker, and there is a lazy checker already, a default one in place. It works within 15 minutes, but you will be able to change this by adding an additional one to say, okay, clear the cache or clear the RAM every 5 minutes, for example. That is totally up to you. You are able to set this by after starting your after initializing your storage manager. Yeah, the default is 15 minutes at the moment, and on 75% memory quota. Okay, so let's get into the research part. So let's have a look. I prepared a lot of different cases, and let's just have a look on the memory consumption of the Java virtual machine, and let's add some data in it and see what happens on the different cases, and how does it works in different ways. Okay, for that reason, I created a lazy demo project, and I want to share this with you. It's also part of GitHub. Just a second. Lazy demo. Okay, so here we are. Okay, this is the link. If you want, check it out, and you can start on the master branch here. And let me just introduce you the project a little bit. So in that master branch, or so basically we have one JSON file as a mockup file. In it, it consists of 1,000 customer objects with first name, last name, email, gender, IP address, and 2 additional values at the end with yeah, I couldn't exactly say how big the strings are in it, but yeah, there are some big strings at the end, and the object is the domain object is that person here, and you can see these 2 values here are some bigger strings to increase the memory a little bit. Whenever we call person controller, whenever we call the create person method here, it iterates through these JSON file, loads the persons, and stores it to the storage itself. And let's have a look to the data root. In that case, we store the persons directly without lazy loading, directly to a list of persons, and let's see how much memory do we need for these persons. Yeah, let's get into it. So I apologize for that many windows and then have to switch from one window to another, but yeah, it is as it is. Okay, so let's start the application. Let's say a nice Java application. So we need the browser to trigger. So let's say localhost books create. That should be the right. Here we don't have a storage in place. Up and running. Let's check the visual for M. This is the monitor. Okay, it's quite interesting. This is the memory consumption we have at the moment. We are at about, yeah, let's say 11 megabytes. Okay, so let's create. One moment. Persons create. Okay, so again, we need this. Let's say a localhost person create. Okay, and here we go. Okay, now the persons are created and also stored. And so we have now, there are 200,000 persons in the storage without lazy loading. And after pressing garbage collection, so we need around 1 GB of RAM in the application to have all the data inside the RAM. By the way, let's check the data on the hard disk. How big is the data on the hard disk? So let's have a look to that. Data, let's check the channels and also, okay, so we are something between 1.5 and 2 GB on the hard disk. So you can see it's not that much overhead within the RAM. I would say it's a lot less than the data on the hard disk. So that gives you an idea of, okay, how much memory do I need to keep the data in the RAM? Okay, something to add from your side. Any questions so far? That was the first case. Without lazy loading, just loading the data. And I think the special thing is, let's stop the application again. And I'm not sure if there is, get UUID. Yeah, that's an interesting point. So there is another method here to just get the UID of the person. And let's see what happened when we call this one again. So let's start it. Java application, we need the visual VM again. So let's open monitor and we need the browser to load. Let's see what happened when we load just the UUID of the persons. What happened? And I would say, yeah, it's not really a surprise. It's nearly the same. It doesn't matter if you want only to show the UUID of these persons. The whole persons has to be loaded, and that's the reason why we have the same RAM consumption, yeah, as before. It's not a really surprise. Okay. So, any questions so far?
So for 1.5 to 2 GB of disk data, we need 4 GB of RAM.
Sorry, 4
GB of RAM.
For how many? 4 GB of RAM for how many?
Yeah, for 1.5 to 2 GB of disk data.
You will need 1 GB. So sorry, for 4 GB of disk.
Can you open your monitor too, please?
Yeah, of course. So now we have. Let me just check the. So this is the disk space. 1.5 GB on disk. And we have around 1 GB in the RAM. When we don't use lazy loading.
Okay, thank you.
Okay, so let's move forward to the next case. Okay, so let's go to next. Let's go to lazy. So now let's check the DB, or especially the data root again. Now, as you can see here, I changed the list of persons. I wrapped it into a lazy segment or a lazy object. And let's see what happened when we use this as lazy references. And especially we have to enable the lazy checker. So that means when I load the data, it needs 1 minute to release the data from the hard disk after last touch. So okay, give it a try. So start the application. This is no longer needed. We need a new one. Here we are. And let's call persons/create. Okay. So at the beginning, we should have the same memory consumption as before, because we have to load the data. But after 1 minute, so that means person are successfully created, let's say at 2:26. Let's wait a minute. So let's check, guys. No, we are not. Gives me time to drink some more tea. Okay.
While we are waiting this cleanup task, will it gonna run with the house cleaning job?
Sorry?
So this cleanup task, will it gonna run with the house cleaning job?
Yeah, this is part of the housekeeping, and now, yeah, not exactly with the housekeeping. It's it's an own thread which is running and which checks, okay, how old is the data at the end, and it's not part of the housekeeping. It's more, it's an extra job, I would say. Okay, now you can see the data is released. So at the moment, we need 320 megabytes to have the data inside the RAM, the lazy wrapped data, I would say. So, and whenever we want to load the data, it will be loaded from the hard disk. There is, some people ask, okay, so what is this small amount of data? Let's do a heap dump to see the data inside the memory and which classes are part. And this is quite interesting because this default registry, this object registry data, this takes a lot of RAM, but in the future, in one of the next versions of MicroStream, this will also be gone. So also the lazy memory consumption will need less memory in the end. Okay, these are the storage entities which need to be registered in MicroStream, but yeah, this one will be gone in the future. But I would say that's okay to have 320 megabytes for 200,000 objects in the RAM. But yeah, what happened if you want to see the data? That's called persons. As I said, the data has to be loaded from the hard disk again. Just to check in that branch, maybe the controller is a little bit different. get persons, and it returns the UUID. Ah, okay, it needs a little bit. Okay, now we are here. Okay, now the data is loaded from the hard disk. You can see the UUIDs, 200,000, and yeah, I would say it's not a really surprise. It's the same result as expected. Okay, so what is the problem here on that? What is the basic problem on that solution? Have you an idea? So is that a good approach, or what is the problem here? So as I said, it will work on low and medium sized collections to load the whole collection at once. I'm totally fine with that. But on huge collection, this will be a problem, because whenever you want to stream through that collection, you have to load the whole collection at once. And this is, in some cases, this will be a problem. But on the other hand, if this is a core functionality of your application, you have to think about if this makes sense to have the persons lazy loaded. For example, if you have 1,000 concurrent users on your application server, and all these users want to search through the persons here, then it makes no sense to have them on the hard disk, because you have to load it all the time, and the persons will stay until release in the memory anyway. So then it makes no sense to have this persons lazy loaded. Okay, so we need to find another solution. What else can we do to make things working better? So let's move on to the next step. So let's switch to the next branch, which is called change to multi-maps. Yeah, let's do it like this. So discard changes. So this is another approach which could be quite helpful to you. So you can see it's a little bit different. So we have one person domain object. It's the same object as always. And we have a second one, which is called persons. And when we open persons, we see a structure like this. We have persons by last name, persons by mail, and persons by ID. And when we talk about ID or mail or last name, we are talking about to have only the very first 2 digits of the last name or of the mail or of the UUID as an index in that string. But we have the persons, all persons inside these lists here. And not exactly, but yeah, in a way. So we create an index as we need to find the data. But some people might say, okay, now we have persons here and again here. Does this triples the amount of RAM we need? What do you think?
No.
No, that's right, because these are only references to one existing person in the RAM. So of course, it increases the memory a little bit because we need more reference. Each reference needs a little bit RAM, but this could also be a great solution. But there is one problem on that solution. So especially with my example here, I load the persons. Okay, what happens? So I'm able to click on create or load persons, and 200,000 persons will be created. But I have only 1,000 persons here in the JSON, and that means I'm adding the 1,000 persons again and again, 200 times, always the same person. That means whenever I want to add persons to that 3 list, I have to open all that list again and again. And that means the whole structure. So that means it slows down, but adding the data will, to add data will increase the amount of RAM more and more, the more often I click on create persons, because when I click 5 times on the button, or when I call 5 times create person, the storer has to open these persons completely. So, and that means all the data stays in the RAM, and this will become a problem the more persons I add. So especially for adding the same persons at once again and again, this is not a good solution, I would say. But yeah, let's say that I'm not sure if that is a realistic situation. But this could help a lot for you to have a string to search in it and to find a date, the date. But there is another case. Let's have a look to the next case. Let's switch the branch again. And I would say this is a quite easy solution. Let's close this to clean up that a little bit. Okay, person stays the same, and let's have a look to the data root class. What about this solution? I think it's the same on the value side, on the key side. So it's a little bit different because I store the mail together with the UUID, or together with a random UUID in the string as a key to find the right person. And I put one person as a lazy wrapped person on the value side. And this is a really great solution. And I want to show you how this is working. So I have the big system. I have to just, so let's change the name. So I created a lot of persons before the training, and now I have around, that is no. Now we are right. Okay, so now I have 1 million persons in that collection, and this is around 8.8 gigabytes on the hard disk. So let's see what happened when we load the data now in that structure. So let's say, just check the controller class. We will not need to create persons. The persons are already in place. So we have the get person, get all persons. That's I think, but this is the interesting one. So I try to find a specific person depending on the mail. Okay, so let's start the application. So run as Java application. We don't need this anymore. Monitoring. Okay, there should be also an init. This is just to initialize the storage. And let me use my Postman for that example. Training, lazy exercise, and find persons. What is that? Okay, let's do it directly with the thing. Okay, let's have a look. The database is up and running, and let's try to find a specific person by mail. Okay, here we are. No, not by mail, by mail. So Hey, this is quite weird. The URL is missing. Give me just a second. So localhost 8080. Person's last name, and it's not sure. Is it a param? But it's male, right? So okay. And we need one male as an example. Oh, come on. So here it is, mockup persons. Just take one male out of that to find. I have a chance to find one. Okay, now it should do the trick. So let's save this. Person's last name not found. Maybe the port changes. No. Ah, okay. It's /mail. We need persons /mail. Yeah, now you can see it starts up. It needs a little bit to initialize everything because this is the first call, but we now get a result. Okay, here we are. It's 14:55 seconds. That's quite a long time, but it's the first start of the storage and it needs a little bit. Let's try to find another person. So let's use another one. Should be much faster in the end. Let's do it like this. And you see, there is another, right? It's 25 milliseconds out of 1 million entries. And let's have a look to the memory consumption. And you see the memory consumption is now 1.5 gigabyte around. And I think you will be able to find every mail. So let's change to this one. Let's say send. You see 22 milliseconds. When we search longer, we will get a much better result. And in the end, the memory consumption stays the same. For 9 gigabytes around, you will have 1.5 gigabytes of memory consumption on your server. And I think that's quite great, especially with one of the next versions. Let's create another heap dump to see. Okay, it needs a little bit because a lot of data is in it. Yeah, and you see this red one here, this big one here. This will be gone in the future, and with one of the next versions of MicroStream, you will only have these elements here. These are needed, and this, yeah, as I said, will be gone in the next version. But also in that example, I think that's really great working also with a huge amount of data, and I think that gives you an idea for the use case of MicroStream and how to use MicroStream in the end, and what's possible and what is not possible, and how much memory you will need in the end. I think it's just give it a try and find out how does it work for you, and which data should stay on the hard disk and which one is needed in memory. Yeah, I think that's show the structure again. Which structure? The heap dump or Oh, I created another one. This one? Ah, the class itself. Okay. This is the person class.
So how many people are there in the storage?
In the storage, 1 million at the moment.
1 million.
Exactly 1 million. The lazy items are inside the data root. You can see it here. It's a map. And the map consists of the mail and a random UUID. Don't ask me why I added a random UUID. This could also be some more information of the person entity, some fields of the person. For example, p.get name or last name or something else. In some parts or on some projects on our customer, we use a normal integer ID or a string ID, and we have an additional Lucene index to search within some specific fields of the person, and then we get the whole person object out of the map. There are many, many different possibilities to use MicroStream in a proper way within your object graph. It's totally up to you. I think, I mean, it's normally you would create an object graph depending on your database, because you have a database structure. It is normalized, you know all that relational stuff and so on, and you know all that normalized data in it. And you need to create a best fitting Hibernate configuration to get, and you have to create specific domain objects which are working with the Hibernate stuff together with the database. And that means you have to create the structure depending to your database. With MicroStream, it's a little bit different, because you have to create a structure which fits best to your application at the end, and not to the database structure. Sometimes it's a little bit challenging to find the right structure, especially with lazy and so on. But to be honest, after a few weeks of working with MicroStream, that is really straightforward, because it's just Java. Yes, that's right. So all the items are lazy loaded. Only a few small informations are part of the key here, because I want to search within the key. And that brings me to the point that I not have to load all persons at once to search for one or two specific persons. That's why I have a small index as a key, and this works really great in the end.
Is there a way to using pagination with the lazy loading?
Yes, there is. With the upcoming version 8, there is a pageable collection, which is part of MicroStream, and it pages the persons directly. So that means you will be able to use a normal list, for example, or you can use it as a list. And when, during the streaming, when you stream through the list, it will pages the data and release the data automatically. So with version 8, there will be a pageable collection. The pageable collection is part of MicroStream. But you have to know. Let's imagine we have. Let's say we have 1 gigabyte of data on the hard disk. 100 gigabytes of data on the hard disk. We will be able to make a lazy loading for every data. So that means that the memory consumption on database startup is not that much. But what about concurrent users are starting to working with that data? So the data has to be loaded and so on. And the biggest or the interesting question is, how much memory do we need with all our concurrent users in the end? I think that's more important as the question to how to bring the data or how to get data inside the MicroStream. So it's stuff for huge discussions, I would say. But yeah, just try it out. And I would say there is another point which is really interesting. MicroStream is specially made for microservices and for a microservice architecture. And this architecture is quite different to the I would say huge databases, and so it makes more sense to not have one big tree of all the data, instead of using a lot of smaller tree with memory that belongs together. So that means you should have one tree for persons, for example, one tree for companies, one tree for orders, for example. That makes more sense in the microservice architecture. And that is the case where MicroStream becomes more and more useful, even with smaller data within microservices architecture. And this is what MicroStream is used for. And maybe it's not created for those big terabytes of data databases. It makes more sense to keep 90% of the data on an Oracle database, but for the small amount of data which is needed in a high-performant way, you should use MicroStream within a microservice architecture. I think that's the message, basically.
Would we be able to set the size of the collection?
Again, sorry, the file?
Would we be able to set the size of the collection?
The size of the collection?
For the pagination.
So 1 million objects are inside the collection here. The map contains 1 million objects. It's around 8 or 9 gigabytes. So the first example project was 200,000, and it was 1.5 gigabyte on the hard disk. You remember? And now you can calculate 5 times more. It's around 8 or 9 gigabytes of data. Now we have 1 million persons in it.
Sorry, my question was not clear enough. Would be able to set the size of the pagination in pagination collection when it will be
That's a good question, but I am not able to answer that because I haven't seen this collection yet. So it's under development, I would say, and I didn't test it so far. So it needs a little bit. But I think it would be possible to adjust the how to say the scrolling size. So yeah, it would be possible to adjust this. I think that's quite clear. So we have one question: what are the biggest collection you used in production? That's a good question. At the moment, we have the biggest collection. So the amount of objects, I would say the biggest one are around 100,000. That's the biggest collection we have. But I think the interesting part is how big are the objects of that collection. And these objects are really huge objects. These objects are, like I say, this is data from just a second. what is the right word for it? These are sanction data for different countries and companies, and these are data that comes from another service, and these objects are really huge, but the size of the collection itself is 100,000. And sometimes it makes sense. Also, that's also a good point. We have to talk about this, especially for the lazy person here. So let's jump back to the person here. So we have first name, last name, mail, gender, IP, and so on. And especially when you have some REST consumer or something like that, sometimes you will get huge objects with a lot of amount of fields in it and so on. And sometimes it makes no sense to store these objects in an object form. Sometimes it makes more sense to leave these objects as they are, for example, as a JSON string, and just store the JSON string as it is, because all these different objects here needs a small amount of RAM for all the references and so on. And sometimes it makes more sense, for example, to have first name, last name, mail, gender, and so on within one big JSON string. Of course, you have to parse this string in the end when you want to see the data. But yeah, then you want to see the data, you have to parse it. Otherwise, it stays on the hard disk, and it makes more sense to have one string, one JSON string instead of having a lot of references within one object. So that could also make sense. We also do this in production at the moment. Okay, do you see then any disadvantages regarding search and filtering performance? Good question. I would say basically not, especially I would be a little bit concerned when we are talking about terabytes of data, for example. Not sure if that will work, but yeah. But with all the projects I know, so especially for that parts I'm talking about, the JSON string, for example, we do it in the same way. We have all that JSON strings stored in one hash map in the same way like the persons here in that example. So data root here, but we have the most important fields of that person. We extract it from the JSON and we stored it in a small Lucene index, and we search within that Lucene index within the project, and Lucene returns an ID, and based on that ID we go to that map and get the data out of the map. Yeah, that's right. So hash tables are also great. That's right. So I think the advantage of Lucene is the great search mechanisms and the search algorithms, and also the size of the strings within the Lucene index are much smaller than to have it within those maps as a key, and that makes sense to use an internal Lucene. But in some cases, you should. Yeah, it's hard that Lucene creates those indexes again and again on startup, for example, and this could be quite challenging because of the CPU consumption. Lucene needs a lot of CPU during the building process of the index, so you have to take care about that. Okay, the question is, the question about that is hundreds of millions of records. So are these records, you need such a huge performance, or do people waiting for that calculation? Or do you click on a button and say, okay, give me the result, 1 or 2 seconds, okay? And what technology you use at the moment? Just a normal SQL for that, or do you have some caching mechanisms in place? Okay, and that's a good example, because many people have a structure like this. They have a huge database in the background and use a lot of different caching mechanisms in between the application server and the database itself. And you always have to pay for each part of your infrastructure. You have to pay for database, you have to pay for the caching mechanisms, especially for the RAM, which is used by, let's say, a Redis cache or a Hazelcast cache or something like that. And then at the end, you have also to pay for your application server. And especially, so yeah, so many different technologies, and you need to know that much. I think MicroStream, it is much easier than to have it within MicroStream, or to use MicroStream to handle those data. But yeah, you have to find a good solution for your business case, I would say. Okay, Q-Link. I've heard of that, but yeah, I've never used it. So I all the time hear some people say, okay, you have to use DynamoDB. DynamoDB is the greatest database on earth, and it costs nothing, so you can use it. Have you ever tried to find some, or have you ever looked for some cache mechanisms for DynamoDB to keep it fast? Then you have to pay real money for DynamoDB, and it's quite expensive to enable those caching mechanisms, especially for DynamoDB. And then it becomes more and more an in-memory database. So it's the same like MicroStream in the end. But okay, a lot of points to discuss. That's what I said. We are able to discuss the whole night to that and see all the different use cases and so on. I would say it's it's time for a small break. Oh, okay, so let's move on. I want to add 2 additional topics, which maybe are quite interesting for you. I created, the idea was to use MicroStream on AWS Lambdas, and I created a small project, and the idea was to split up the whole storage into really small segments within microservices, to have a database in the end, which costs nearly nothing, I would say. Or let's say it only costs when you access the data for a short time, as you know, as the Lambda approach works. And I created a Micronaut application, especially for Lambdas, for AWS Lambda service, in combination with MicroStream. You can find it here. And basically, it works really great. So the idea is working good. You have to take care about memory sizes also on AWS Lambda, but and you have to find a good solution to keep the Lambdas in hot state, to have good access, I would say. So as you know, Lambdas are, there is a running state and you have to pay for it. Then you have a hot state and you have the cold state, and you only have to pay for running state. But when you keep the Lambda in hot state by using a small, let's say a small ping or something like that to keep it hot, then you will get really incredible response times from that Lambda, and you can use it as a database. And I stored the data within an AWS S3. Yeah, it works really great, and in my opinion, it's a quite interesting use case with MicroStream. Okay, so just try it out. I pasted the link to the repository in the chat. And another interesting point is the second one. What do you think? What are on AWS? What are the biggest machines on AWS? How much RAM is the biggest one you will get?
384.
Sorry?
Should be 384 gigs.
Okay. Someone else? So AWS releases a memory especially for SAP HANA with these amounts of RAM at the moment. That is also quite interesting. So I don't care about
normal instances.
I don't care about RAM anymore, but yeah. But this is also quite interesting. At which cost? Yeah, that's the good question. That's a good. I don't know, but to have 6 terabytes of RAM, that's incredible, I would say. Okay, but when you have to deal with that amount of data, you will be able to pay this. I'm pretty sure. Okay. Yeah, let's go on with the next topic for today. Let's talk about legacy type mapping. What does that mean? Legacy type mapping, it's all about what happened if my data changes. So what if the classes changes, and how to handle this, and what are the differences between MicroStream and relational databases? Let's talk a little bit about that. Okay. Yeah, so first we have to talk about how does MicroStream handles data types, basically. Then we talk what about we have to do with when we change something, and what changes can be handled automatically by MicroStream. And you could find all topics again within the documentation. And yeah, let's get into it. So at the beginning of the training today, we saw all that files on the hard disk, the channel files, and also the interesting one, the persistence type dictionary. So, and this is the file, and we can see it here. And the persistence type dictionary contains all the different objects of our storage. And each object has its own object type ID. It's this number here. For example, that's the type ID, and there is another ID, which is the object ID itself, and each object has its own object ID, and a type has its own type ID, of course. So that means let's have a short look to one of the storages we used in that training. Let me just check if there is, yeah. Let's get into this. Open with text editor. Let's have a look here. So this is the persistent type dictionary, and here you can see all the primitive types and also the object types, integer, longs, doubles, and so on, and all the types which can be stored within MicroStream. And if you want to know which types can be stored in MicroStream, you will also find a list within the documentation. It's part of the addendum here, and supported specialized type handlers. Yeah, these are all the types which are handled by MicroStream, also records and so on. The only thing I would not recommend is to store third-party objects within MicroStream. That could lead to a painful thing. So don't do that. Don't store any third-party objects within MicroStream. Okay, the reason for that is, so let's scroll down directly. For example, here you can see this is one object we created within the project. So for example, the author object, and you can see there is a second one, which is also called author, but with different fields in it. And this is the way basically MicroStream works. It's kind of like a versioning. Whenever an object changes, MicroStream creates a new author object, and that means then in the end you will have old author objects in the storage, and you will have new one. And whenever you touch an old one and store an old one, it will be automatically migrated to the newest version of an author. And this is how the legacy type mapping basically works. So as I said, each entry in the storage has a type ID and an object ID. Each type in the storage has its own type entry in the dictionary. That's also important. Just a second. So that is also important. The persisted type dictionary is a very important file. When you lose that file, you will not be able to read your storage again. And if this type ID is missing in the dictionary, the storage will not start. So that's important. Okay, as I said, there is a list of supported Java types within the documentation. We already, and this is what I've talked about. So we have an old customer and a new one. And in this case, the male, or no, we have another additional field, for example, the gender field. And that brings me to the point I explained. We have old ones in the storage and new ones. And whenever you touch and store an old one, it will be migrated to the new version of the object. Okay. Of course, keep in mind, after removing an attribute, the data is also gone. That's, yeah, I would say quite obvious. So let's have a look what changes can be handled automatically. So this is one example. So we have contacts on the left and contacts on the right. The right one is the new one, and the old one we changed. For example, the first name attribute moved to the first place on the class. Then it is moved, handled automatically. Name is changed to last name. Then it's only renamed. It's handled automatically by the MicroStream. Age is deleted, I guess. No, it's also moved here to the bottom place. It's moved. Then email is changed and renamed. And there is a new one, which is note. No. String email. No. So address is the new one, of course. And note is renamed from note to note. Okay. How does MicroStream know that these changes are made? Okay, how is that possible? So there is a heuristic in the background which measures all the different properties of an object. For example, the name, the data type, the different digits of the name, for example, and yeah, he decides what could be the right change in the end, and it will show you a list like this in the end after starting the application. So we have, for example, we have first name is first name. It's the same 100%. Name to last name, it's about 75%. That this is the right change. Email to email, and you see the heuristic measures the possible change and shows you before starting the storage itself. And when you agree with that, when you say, okay, that's everything is right, so it's, then you can accept this by typing a yes, and the application will start up. Okay, many questions. Let me start. Okay, try to understand. I heard only threads could not be serialized, but every other serializable object could be. Okay. That okay, not okay. So let's go on. I think that will answer most of your questions. That is the basic step. The heuristic is the basic step, and I would say in 95 of your cases, this will fits best. I'm pretty sure because I'm working. I work with MicroStream that so a long time, so it's working great all the time, and it is working that great that it's quite hard to find one case which is not working as expected. So yeah, let's do that. So some best practices are interesting when we're working with legacy type mapping. So during the development, when we are able to delete the storage all the time, this is the first choice. So don't use any legacy type mapping during the development. Instead of having good mockup data in place to delete the storage again and again. And when you have some changes on the storage, just delete the old one and start it with a new one. So I would say that's during the development, that's the best practice. You should not do multiple changes on one object. This could lead to some errors sometimes, but most of the time it is also working great. Of course, you should create a backup of the storage before updating, but that's also, I would say that's, yeah, really straightforward. And in some parts, we are not able to do this automatically, especially when you have some data migrations, for example, from string to integer or from integer to string, something like that. This could not be handled automatically. You have to do some manual stuff, but let's talk about that later. First, let's have a look to an existing project. So there is one which is called legacy type mapping. Let me share the GitHub link for that. Legacy type mapping. Here we are. Okay, so okay, so I understand, Christian. Yeah, that's most of the third-party objects will work without any problems, but in some, especially when the third-party framework do some updates, for example, then these objects might change, and that could lead to trouble because you are not able to, especially if it's closed source or even when it's open source, and sometimes you have to deal with the changes inside the classes. and that could be a problem. But basically, it will basically work to store the objects without a doubt. But especially when some framework updates comes up, that could be a problem. Okay.
What example? Do you have example? What kind of updates can be troublesome?
One of the most, I think the worst case would be, let's say you store a third-party type to your database. So, for example, let's have a look. Let's go open this. So, okay, no. Open with text editor. So, okay, so let's say this author object is a third-party object, and you can see this is the full qualified name. So what happened if this object is moved from one class path to another? Then MicroStream is no longer able to find this object on this class path. And this could be a problem because MicroStream tries to find this object, but it's not able to find it within this class path, you know?
Okay, so even in production, we should be careful when changing the packages.
So yeah, especially when it, especially by, it's the same on your own framework. When you move one class to another section or folder or package or something like that, you have to deal with it within your storage then. And maybe you have to change your persistence type dictionary that brings that MicroStream is able to find this object again. So it could be the case that you have to change the persistence type dictionary by hand. But there are other ways to handle that. So that brings me to the next part of the presentation. But let's have a look first on the heuristic and the basic stuff of the legacy type mapping. Okay, we are on the master branch, and let's have a look to the author object. So we have male, first name, and last name in place, just a few fields. And let's start the application and create an object. So let's delete data. We don't need this. So I will call the create method in my browser, localhost, and this is authors create. Okay, you can see MicroStream is starting. So now let's have a look. Okay, so you can see it here. I created one author, and it's male, first name, last name. And I think the important things are male, first name, last name. Let's move to the next branch. So stop the application. And in the next branch, I changed the names here of the author entity. Switch to changes stage 1. And as you can see here, so we have male author now, we have first name, we have name. And when we have a short look to the database class, then you can find this additional entry. So that means that we use the legacy type mapping resulter, and that leads me to the point that I have to press yes to accept the migration from one type to another. So when we start the application now, and let's try to load the author again, then you will see, okay, MicroStream says, okay, something has changed. Mail could be moved to mail author because it's 70% the same. First name to first name, it stays the same, and last name is moved to name. And we are able to type yes if we want that. And MicroStream starts up and everything is great. And you can see it here. Now you see it has automatically changed the object, mail author, first name, name. It's the new structure we want to have. And this is working really, really great. But let's move to the next example. So, and I try to find a good example to create a problem. And so we have mail author, first name, name. Just a second. So, and now move to the next case. Team. Stage 2. Yes, we no longer need this. Okay, so, and now I added a few more mail fields, and the idea behind this is I exactly want to have the value from the field mail in the field mail 6. That's the point. So normally when I start this, and I would use the heuristic, he would try to add the values of mail author to mail 2 normally. But there is a way to do a manual, or let's say it's also part of the presentation. No, that's the wrong one. This one is the right. So yeah, just a second. There is, how to say it? One moment, please. Storing data. Is it type mapping? Okay, let's have a look into the documentation because it's quite a huge topic. So this is, we already talked about automatic mapping. This is working really great as we talked with the heuristic and so on. And there is another way to do that. It's an explicit mapping. So that means we are able to specify the exact way how to move the data during some changes. And this is made by, let's say, by refactoring a CSV file. So that means you are able to create a CSV file. On the left side, we have the old ones together with the full name, and this is the new one, the current one. And we have to specify to which field should move, or which value should move to another value or to another field. And I already did that in that example. I created the refactoring CSV. Oh, come on. Every time it's the same. Okay, it's this is the refactoring CSV. We have the old and the current. It's separated by a tab. This is the old one, and this is the new one. And regarding to your question from before, what happens if a class moved from one place to another? This could solve your problem, because just add the new path of the object and move it to another path, and that will fix your problem. And it's the same with the mail author here. So I said, okay, move mail author to mail 6. And let's start the application again. Okay, there is no storage in place. Just a second. So
is there any convention for this file name? How you load it?
I will show you that. Give me just a second. Application, I have to create a storage first. So, okay. So authors/create. Okay, let's ensure that it's in place. Okay, you see, mail author. And now let's move to the next branch. Okay. The refactoring CSV is, that is crazy. We have it here. And now let's start the application again. Access the application. So let's call this again. And now you can see it uses now the mapping file. So mail author is automatically mapped to mail 6. And this is the way to ensure the mapping, or to do an explicit mapping. But yeah, it's working really great. It's up to you to use that explicit mapping. And I would recommend that, especially when your application is running on production, then it makes sense to use that explicit mapping. But yeah, to be honest, I never used it also in production. Most of the time, the heuristic did a great job. And if there are some special stuff like let's do some migrations from data type, for example, from integer to string, or double to integer, or something like that, then it's more important to use a different way. In that case, most of the time we create, for example, another field, and adding some business logic to transform the data from one field to another, and the business logic stays in the application as long as the last object is upgraded to the newer version, and then you will be able to delete the old field. Okay, how to regarding your question, how to add the refactoring CSV. So it's here. So this is create embedded storage foundation, and then you have to say, okay, set refactoring mapping provider, and this is how this file is loaded. Persistent provide mapping, and this method is used, and this method provides the mapping as a string to the refactoring mapping provider, and this is how it works. You can find the same code also in our documentation. It's the same. Is it enough to write a constructor? That's a good question. For every new object, sure, but for the existing ones, yeah, for the existing ones, and how should that work? So what is the idea behind the constructor? No, so no, we don't use the constructor. That's right. Yeah. But so, for example, let's say we don't have a good example here in place, but let's say mail 6 is a double, for example, and we need to have an integer instead of a double within mail 6, and that is not possible. So what we do now, we create another field with an integer in it, and let's say mail 6 in, for example. So we do it this way. Then we start up the application, and there are many different possibilities. We for example, we copied the storage from the production system and we did the migration in the background for all objects. So that means we copied the values from here, we migrated to here with some smaller business logic. But it could also be possible to say, okay, let's change the getter, that this business logic is handled by the get method. It could also be possible. I think there are many different possibilities to move or to add some migration code and to migrate the data. But in the end, when every object is moved, you will be able to remove this and use the other one instead of. But yeah.
How can tell that every object has been moved, because that will be binary files, we can't see, it is not database.
Can you repeat this, please?
So how can you tell that every object has been moved, because it is not a database? These are binary files, we can't look into them.
Okay. You will not be able to see that, but yes, you are able to see that. There is. Let me just check this. It's not part of the advanced training, but there is one possibility to have access to the database without. There is a client UI, so you will be able to activate this REST interface, and with that, this is only for development purposes. And there is a client UI, and with that client UI, you will be able to access the storage, and you can see the object IDs here and the object within the storage. And this. In that UI, it could be possible to see which data types or which object IDs or type IDs are still in place. But I think that's not the case. It's not that important to delete the field. Most of the time, we keep the field inside the entity because, yeah, it is not a big problem to keep it. And I would think you could try it. Just remove the mail 6, remove the object from your persistence type dictionary and try to start it, and you will see if there are still some objects in it based on the old one, then you will get an exception. That's also a good indicator to remove the mail 6 field or not.
Okay, and one other thing, correct me if I am wrong. If the collection is lazy, unless we call it, it will not gonna change.
That's right. Yes, it will stay in the old version. Yes, but yeah, that is quite normal. Keep it in the old version. Nobody cares about that. When the object is not used that much, it's not necessary to migrate it. Then it stays in the old version maybe forever. So it's not, that is not that important, I would say. As long as the object is not touched or something like that, it stays in the old version. I think that is not a big problem, isn't it? Or what do you think? Okay, so legacy type mapping. What happened if something changed in my class? Let me just check if I forget something. Yeah, as I said, it's a really huge topic. There are some special things to know, maybe, and you can see this is the whole section of legacy type mapping and special cases, how to delete a class, for example. If this is important for you, just check it out. I think you have to know the basic stuff and how MicroStream basically works with that legacy type mapping, but if there are any special things, just you will find it in the documentation. And there is another thing we talk about. It's the legacy. So it's that customizing part. And there is also a legacy type handler. You will also be able to add an additional custom legacy type handler. And this is, wow, that is really mind-blowing. Even I don't know how to use this in the right way. So we have to talk with Florian, for example, our lead developer, I would say. But yeah, that is, it's possible. And especially when some customers ask us to write one of these custom legacy type handlers. And then this is a service we did for our customers for real special cases. So, but it's not made for everyone, I would say. And it's also not necessary to do that all the time. Okay. Any question to that legacy type handling? So we do not longer need this. Don't use the. Okay. So if there are no questions, let's move on with the next, or with the last main topic, I would say, for today. It's concurrency handling. And I would say it's not a main topic for MicroStream itself, because I think it's an all-over concurrency, handling with Java. But it's also quite interesting, especially with MicroStream. So let me just clean up a little bit. So close all concurrency. So let me share the GitHub link. And this is the last GitHub link I have to share for today. Concurrency. Okay, here it is. But first, let's get into a small presentation to talk about concurrency overall. Okay, do we need to take care about concurrencies with MySQL, with MicroStream? Is MicroStream responsible to take care about concurrency? Possible steps to solve concurrent access, proper data model, immutability, locking, concurrent connection. Let's talk about all this stuff. But the first important question, what about, for example, MySQL or Postgre or Oracle? I think it's part of every relational database. So let's say we have a database on the left side, we have an application server, and we have some clients on the right side. Every client has its own device with its own data. So obvious, we have no concurrency here on the client side. Let's go to the application server. Each client has its own session on the application server, especially by using Hibernate, for example. Each client has its own session with its own data, except the cache, of course, but the cache is handled by Hibernate, so this is managed within Hibernate. So we don't have any concurrency here. And at the end, on the database, we have a transaction queue, insert, opted, insert. This is all that stuff is queued. So in most of the cases, it's single threaded, so we don't have to take care about concurrency. most of the time. In some cases we have, but in the basic stuff is really straightforward, no concurrency here. Is this an issue with hibernation? That would be interesting. Can you add some further information? So basically, I would say with Hibernate, you have that object lifecycle. So that means Hibernate takes care about the object lifecycle, and it's a detached, attached state, and so on. And this object lifecycle takes care about concurrency, and also it's also the same on the database side. There is a locking mechanisms and so on. So Oracle has concurrency, okay. But yeah, but it's made with optimistic locking, right? So there is an optimistic locking in place. Yeah, pessimistic lock or optimistic lock. I knew all that concepts, but yeah, but these concepts are not state of the art, I would say. Okay, no locking. Which concept is it? MVC. Is the MVC is a model view controller, right? So no? Okay. Multi-version concurrency control. Let me just check. Okay, yes. Yeah. Okay, you are basically right. This is the basic underlying system, what I said with the object lifecycle. So it ensures that the transaction on the database objects has to wait, and this is the case when you try to have an object which is detached. You have first to attach the object to work on it or to change it, and that ensures that only one object could be attached at a time. Otherwise, it is covered by the Hibernate optimistic locking functionality. But I think that's the same. It's covered by the JPA Hibernate or JPA standard, yeah. Okay, so maybe also on the database side, yes, sure. So you are basically right. There is concurrent stuff. Maybe I can add this to these slides. But yeah, to be honest, it's not a great pain for you on the application side, right? So you don't have to deal with that. So it's not recommended to know a lot of that stuff on the client side. This is database side, I would say. So that's also the reason why most of Java developers do not know a lot of concurrent stuff or concurrency handling. But yeah, anyway, I think it's more important. We will see. Yeah, you are right. We will see. Okay, so let's have a look to MicroStream. That's the reason why we do those topics in that advanced session. So on the MicroStream side, when we have an embedded storage, then all the clients are working on one object model. And that's for sure a quite heavyweight problem, I would say. When we say, okay, all the clients are working on one collection or something like that. It's the same when we use an application server. The clients have sessions, of course, but at the end, when we have a storage server, for example, let's say we have a Micronaut application with REST endpoints, then we have to take care about concurrency on the storage server side. So, and that leads us to the point that MicroStream basically, you are responsible to take care about concurrencies, and basically MicroStream do that internally, because MicroStream internally is single-threaded. So to store and add and something like that, it's like a queue, I would say, but not on the object graph side. And you have to take care about your business intelligence. And as it is on that page, it's a little trade-off between performance and complexity. Okay, so what can we do to prevent concurrent access to objects? What is the basic? What can we do? And there are thousands of different home pages with concurrent stuff on it. But all of these pages comes to step one: try to prevent concurrent access whenever you can. And that is quite funny, because we have to take care, and when we use it, it's most of the time it's a performance issue in the end. Okay, let's say, first of all, we should always use immutable objects, or we should use immutable objects whenever we can. That means use the final word as often as you can. And if it's possible, try to reduce the amount of concurrent access as much as possible. Changing data model, for example, or change application architecture if possible. And if not, you are able to use the word synchronized, for example. But yeah, we all know synchronized is a little bit of a problem, because let's say, it don't differs between read and write access, and that's a problem, because the read access isn't that a problem, but the write access is a problem. And we can use synchronized, but we are able to use it. So whenever we have, let's say we have collections which are not that frequented used, we could use synchronized. That will be okay. Or we can use synchronized collection. But there are another things we can use. For example, the concurrent hash map could also be a possible way to handle concurrent accesses. It's available in Java, and I don't want to explain how it works exactly. And most of the time, I do not understand it exactly how it works. But what I can say, basically, it works great most of the time. But it's, as I said, it's a trade-off of performance. The concurrent hash map is not made for huge amount of data, and it slows down the access enormous. So it's possible to use, but I would say it's not my favorite. But it is working. It's working okay. Concurrent hash map. There is an example within my project. Try it out.
I have a question from step 1.
Okay.
So if you use mutable objects, will it gonna have some side effects on MicroStream? Because now we are changing the actual reference. So
Yeah.
will MicroStream smart enough to know that reference is changed, but not the whole object has been changed? Might be only one value is changed.
No, I don't know if I get it right. So can you talk a little bit slowly, to understand that better, for better understanding?
Okay, so for example, if I use immutable objects to update a whole collection, right?
Okay.
One attribute inside it, and for that attribute, I'm creating a new object, obviously, because it is immutable.
Okay.
Now, MicroStream will gonna see this is a reference update. So
Okay.
will it have side effect on MicroStream? Because before that, MicroStream knows that reference is same, just the values change inside. But now it can see a whole new value. How it will gonna sort this out?
Okay, I think basically it's as I said, MicroStream itself, it's single-threaded and it is working. So concurrent handling within MicroStream, it's safe, I would say. I think the biggest problem is the concurrent access to collections or something else. So if it's okay on the object graph side, and if it's working without exceptions, without concurrent modification exceptions, for example, then it's okay for MicroStream also. So I think the problem is not on the MicroStream storage side. The problem is on the Java side. So in the example we talk a few minutes later, then you will get a concurrent modification exception. And the important thing is to prevent these exceptions. If it's working on the Java side, it will also work on the MicroStream side. I don't know if that answered your question, but to handle concurrency it's more important on the Java side, not on the MicroStream side. If it's working on the Java side, it will also work on the MicroStream storage.
Okay, thank you.
Okay, so concurrent hash map, that is one possible solution. Then there is another one, which is called copy on write array list. I would say it's basically the same. It's a different collection, of course, but it is working the same like the concurrent hash map. And in that point, it's the same. There are tons of different documentation about these copy on write array list and so on. It is also working great on, I would say, small and medium amount of data, and it depends a little bit on the amount of accesses, but you have to try out. And it's not my favorite. And my favorite is this one. It is called the reentrant lock or reentrant read-write lock. It's also a mechanic which is available in Java. And we created a class for you, so which can be used. It differs. The differences between synchronized and reentrant lock is the usage of synchronized is more rigid. So that means it differs between read and write locks, and that is really great because you will be able to set a lock within your Java code, and it's only a write lock for other writes. The reads are untouched, I would say. And synchronized is tied to the block structure and so on. We all know that stuff. And also the reentrant lock has a fair mode. I think it's okay to read this stuff afterwards. I want to get into an example. I think that makes it a little bit easier to understand. Okay, there is I shared the project with you, and there is one branch which is called concurrency step 2 reentrant read-write lock, and there are some more branches with the concurrent hash map and so on. Just try it out. This will also work, but let's have a look to this one. There is one class you can basically use, or three, I would say. It is this class here, read-write locked. This is a class we write for you that you can use it. And the way to use this class is quite easy. So let's have a look to the books. And the books class extends from the read-write locked. And whenever you touch or whenever you access a list of, you can do this within such a block here to say, okay, this is a write lock. And then you can add or change the connection, and the reentrant lock takes care about to handle those. Yeah, it's a little bit like synchronize, but it's more, it differs between read and writes. And here we have some writes here. This is also a write lock. And let's try to find a read lock. Here, this is, for example, a read lock. And I think that makes the differences between synchronized and so on. Let's try it out. I created that. Let's start the application, or let's start on another branch. Just a second. Just to show what I mean when we talk about concurrent exceptions, for example. So team to the master branch. Okay, application. Let's start. I'll just check if data is okay. Okay, application. Okay, I added one method in the book controller, which says iterate. So this method iterates through the books collection all the time. And there is another one, and with that one, I'm able to delete some books from that collection. And let's see what happened when we call first the iterate and then try to delete a book. So localhost books slash. First, we have to create books. Books successfully created. Let's say, okay, books are in place. And let's iterate. Okay, now we iterate through the books, and now let's try to delete a book. And here you can see, oh, we are quite lucky. The first try to delete a book leads us to a concurrent modification exception. And this is the point where we have to take care about concurrent accesses. Let's switch to the implementation of the read-write lock. This one. Okay, and let's do the same. Maybe I have to create the storage again because of the different structure. Okay, run as. So books. Create. Let's show if they're okay. Here we are, books slash iterate. And now let's try to delete. And now you can see you will be able to delete everything. You won't get this concurrent modification exception again. And as you can see here, I can click it all the time. And I think that's the best solution, in my opinion, to use that reentrant write lock. Feel free to have a look to that project and see how it works exactly. It's quite easy implementation, and my personal favorite, I would say, instead of using the concurrent hash map or the copy on write array list. But these collections are also working great. So, but not as good as the reentrant write log, I would say. Okay, so any questions so far? It's also every time interesting to see, okay, do we need a concurrency handling on every collection of our storage? Is that really necessary? It depends a little bit on how fail-safe must the system or yeah, you know what I mean? How consistent or how important is it to keep the system consistent? I mean, it's always important to keep it consistent for sure, but sometimes it's not really necessary, especially on objects which are basically not able to access in a concurrent way. This could also be possible, or objects which could be basically synchronized, and we are totally fine with that. Yeah, that's all I would say regarding concurrent accesses. Okay, so any questions from your side? Feel free to try out that project and give us some feedback to that. But most of the time, this is working great, in my opinion. We use that a lot, and yeah, try it out. A question from Verizon: have you ever heard of the reentrant read-write log? Who of you have used this before, the reentrant? Okay. To be honest, before 1 or 2 years, I've never heard of that before, and that's quite interesting. The first time I worked with concurrent accesses, I used the copy on write array list and all these concurrent collections, but I never heard of that reentrant read-write log, and that's quite interesting. Okay, so let me just double check the topics for today, so to not forget something. Okay, so we talked about storing advanced, we talked about lazy loading, we talked about concurrency and legacy type mapping. Some smaller topics left. This is the customization, but this is only a topic for yeah, a few minutes. We are able to go straight through this. Yeah, this is great. So we are just in time. So let's move on. And I would say it's not that important, but I think it's important to know about, okay, there is something in place we can use, but it's not necessary to use it all the time. Especially the first customization is a custom class loader. In some cases, it's necessary to use it, especially when using MicroStream in combination with Spring, for example, or with some application servers like Wildfly or something like that, because they uses different class loaders, and especially then it could be useful to use the custom class loader provider, and it could be used on the foundation, and then you will be able to add an additional custom class loader. It's also, you will find the same code within our documentation. So to summarize that, you will be able to change the class loader of the application, or especially for MicroStream.
So if this project needs to work with Spring Boot, we have to use Spring Boot class loader?
Yeah, especially for that. Most of the time you use the Spring Boot class loader, but in some cases, it makes sense to set your own class loader, especially for MicroStream. And I knew that because one of our customers needed that, and that was the reason why we implemented it, especially for Spring Boot. But to be honest, I'm not an expert in those things. So if you have further questions to this, just feel free to send a mail, and I will try to answer it together with my colleagues. Okay, so we have one ad from Christian. To be honest, I expected more from a modern persistence framework like MicroStream. Yeah, basically you are right, and in a way, but I would say it's most of the time we try to compare the existing technologies like databases on the market and so on, and with MicroStream. And this is all the time the same. All these solutions have their own disadvantages, and every storage, there is no storage on the market which is perfect. And especially when we talk about relational databases, the point is we all are working with relational databases for 20 years now. And everyone knows every single part of how to deal with that and how to do it that. But think about, to start with a relational database with Hibernate, with all that stuff nowadays, then it would be quite horrible to learn all that SQL Hibernate stuff, normalization of a database, and so on. I think it's not the best way to compare it. So you have to find the best business case for you to use MicroStream. And MicroStream comes with a huge performance impact. It's much more performant than any other storage technology on the market. I'm pretty sure about that. And if you need that performance, then you have to deal with other disadvantages, I would say. MicroStream, the idea of MicroStream is to store data in the same way as clicking on save on a Word document, and that's it. And of course, there are some disadvantages, and you have to deal with it. But instead of this, you will get performance on the one hand, and you will get easy using, I would say, on the other hand, with some special disadvantages you have to deal with. I think that's the point. But you're basically right. Maybe there is a way that we are able to implement this for you. Then this could be a great feature for you in the future. Yeah, why not? Maybe that will be the case. Feel free to add this to our feature list. This is why MicroStream is an open source project, and you are all able to work on it. And you can do it on your own. That's, I think, just find a way to use it, and I think it's a great solution overall. We did a lot of projects with that, and it's up to you. Just check it out and try it out. Okay, let's go back to the custom type handler. This could be a possibility, especially we talked about of third-party objects, for example. It's the possibility to find a way to map an object to another one, to store it to the database in the end, and the way back. It's kind of like a mapping functionality. So whenever you have an object, for example, this one here with an instant from and to, and you don't want, let's say we have millions of instants to store, or millions of time slot objects to store, and an instant has many internal references to some other stuff. And sometimes it is easier to store this instant as a string on the hard disk. And this is the reason for the custom type handler. So just add a method like this to say, okay, let's add a binary type handler for time slot and add some mapping stuff within this method here. And this will work.
I work in that keyword.
Sorry?
Ah,
okay, so let's move on. Custom storing behavior. In some cases, it makes sense to implement directly a specific storing behavior on a specific object. So let's say we have a custom company storer, for example, and let's say, let me just check this. So if the entity type is a company class and a field, the field is a type of an array field, then it returns false. This excludes a specific entity, especially here when the entity type is company class and field type is an array, then it is excluded from storing that field. So in that case, you will be able to add this custom storer to a specific class. Maybe it's more important with that. It's a storing field evaluator. So that means it's possible to add annotation to a specific field. And whenever a field is annotated with that annotation, you will have automatically a store eager functionality. So that means, for example, let's have a look on that customer, for example. And here it is the case. The company is tagged with the store eager annotation. And whenever the customer is stored, automatically the company is also stored in an eager way. So instead of using the storage manager dot store eager or create eager storer. So with that functionality, we are able to create a custom storing behavior. Okay, and last but not least, the custom legacy type mapping. But I'm not sure if I'm able to explain that because that is, as I said, that is so complicated. Maybe if you need that, just give us a call and some of our developers will take care about that. It's basically possible. You just read some points in the documentation, but as I said, it's not made for you as a customer. It's more to use this by our support to help you in special cases, I would say. Okay, these are the 4 important customers. I think it's important that you know that there is some customization in place. And I would say basically that's it. So there are 30 minutes left, but this is really okay. It's time for your questions, your ads, some discussions or something like that. I want to share the link to the Google form. Just a second. That's important. You will get the certificate of the course. So So just to ensure if this is working. Okay. So this is the link. Just fill out a few fields here, and you will get the certificate and also the link to the presentation, the PDFs, and so on. I think that's important. Okay, so let me read your ads. Some results online concurrency of the are kept. No impedance mismatch. Okay. Okay, so yeah, it depends on your use cases. And I think there is no all over technology on the market, especially for all the different needs. I think that's quite normal. So that's quite normal. Okay, some more questions from your side. So it's late at night. For to solve most, I guess, right? Yeah, in most cases, I'm pretty sure you should be able to use immutable objects all the time. Basically, you should be able. Yeah, it might be possible that you have to change some structure, but most of the time it should be possible to use immutable objects. Yeah, and that would solve a lot of problems, of course. I think anyway, it's best practice way to define objects in an immutable way. So that's for sure. That's basic Java, that's right. But nobody is perfect, as always.
There are some use cases or edge cases where we do need locking. For example, if we want to insert something in database or storage, only if it does not exist, then you do need locking.
Yeah, I think so. Whenever you have to, so I think it's more a Java technical stuff instead of a locking mechanism. I think the basic locking stuff is a business case stuff. Let's say the optimistic locking of some relational databases covers only the technical part of the locking stuff. But there is a lot of business logic which needs locking because of the business logic itself. But the concurrency handling is more a technical thing to prevent, especially when you read collections, then you will not be able to delete, for example, some objects during the same time you're reading the collection, and that is more, let's say a technical limitation inside Java. All the other locking stuff is more a business logic stuff, and yeah, it's not hard to answer that in a general way, but it's a huge topic, I would say. I need to cut off myself. Thanks for these great insights today. Okay, thank you. So from my side, I'm finished for today. yeah, it was great fun to do the advanced training. I hope you enjoyed the training. I hope there were some new aspects in Java with MicroStream or something else. Feel free to try out. Feel free to send us a mail with your suggestions to MicroStream, with your ideas, some features, something like that. Thank you for staying with me in that training. I wish you Merry Christmas and a Happy New Year, and stay healthy, and see you next time on any conference or next training or something like that. Yeah, enjoy. Thanks a lot.
Thank you. Happy holidays.
Yeah, you
It was
too.
very helpful. Thank you so much.
Thank you. Bye-bye.